Yes.
Hey, Line. Hey, Simina.
Yes, we start with Simina and Elena, team A4.
Hello, everybody. I hope you can hear me.
Yes.
Great. Elena is going to share the screen.
Okay, have it loaded. Give me a second. Yeah, I'm ready.
Okay, I'll start. So, hello, everybody. We are Simina and Elena, and our project is called Synthetic Genesis. We need new tools, a new body, and a new mind to resist environmental challenges and explore new worlds. In the first chapter, Prosthesis, we started to create a synthetic body by using synthetic biology in order to incorporate advanced communication systems into the human body and into the human brain. The prosthetic suit is a shield against thermal, radiation, and impact threats, but also a highly advanced communication system within the helmet. With the second chapter, the corpuscle was a scientific permanent base in Shackleton Moon's crater. The development had two directions, the exterior protective shield and the habitable space within the inflatables. In the third chapter, Horizon Line, with the amalgamation, we have explored different types of public spaces, both exterior and interior. We also had a DLA network, and with it we have integrated different clusters with different functions by using WASP rules.
In the fourth chapter, Kinesis, we expanded new sites on the lunar South Pole. The need of logical transportation arises. We explored new transportation systems, one public that goes from colony to colony, and a private vehicle that explored the crater. The map of an emerging new world on the lunar South Pole splits up in 3 layers. The first layer contains flying routes, which are most commonly used between colonies. The second layer is consists of explorer paths that are used for researching the terrain. This third layer consists of traffic in and around the DLA inside of the colonies. We started out by analyzing the lunar terrain to see where new colonies could emerge from. Our habitats use solar energy as a primary resource, so we excluded areas which were not suitable for emerging colonies. Due to gravity inconsistencies on the lunar surface, the flight routes are slightly altered and affected by the values.
We also took into consideration the ice deposits that are possible on the moon due to the extreme environment, extreme light, extreme darkness, and extreme cold. The water ice extraction was done by using the DLA network that spreads across the ridges and inside craters. The DLA network also is connected to the roads and connects the colonies. So we have started the catalog. The first layer, the highways, as the primary layer spreads over the lunar terrain, avoiding craters. The highway distribution gets affected by gravity values and light values, and that makes the highway network more diffuse, as you can see in the animation. The second layer, the roads, explore the lunar surface for resources. So in this case, water ice deposits. Basically, this network goes around the craters. The tertiary layer, for the tertiary layer, we have used the DLA network as a base, background information to generate the neighborhood access and water distribution. At the bottom, you can see all 3 layers running together in the animation.
By finding the optimal place for settlement, we used resource values from the DLA and sonar allergy values. We first extracted solar data and extracted the highest value. We filtered them by resource value. We used that extracted data to connect them back to the DLA.
So we have used Response to distribute the functions throughout the colonies. We have integrated new functions within the amalgamations and clusters. We have helium-free extraction sites. spaceports, landing pods, and the most important, the training parks for deep space missions. We managed to make two types of transitions, from rounded to squared and from closed to opened for our units and for our amalgamations. At the bottom, the blue ones basically are the ones that can make transitions from one cluster to the other while they aggregate. Our new public spaces are the training parks for deep space missions, and they are connected directly to the DLA network. We have used the field-driven aggregation for a proper distribution of the clusters. So we have the selected curves, the field, and the aggregated units along the field in different options.
By using these components, new kinds of colonies emerges, shown as here, and here.
Okay, wrap it up. Half more minute.
As conclusion, our synthetic genesis vision for the space colonization on the lunar terrain includes autonomous systems with logistics and independency, a type of community that could govern itself anywhere. Thank you for listening. That was our presentation.
Thank you, ladies.
Thank you.
Impressive work, as always. I'm very happy to see the progress and how everything is coming together in this chapter. I'm also very excited and very happy to see that you're working so well together and you're able to continue the story together and carry it on. For me, there is definitely the storytelling, meaning like all the layers that you were thinking of and incorporating in your design. It's very clear the way that you're thinking. The story is cohesive. You are thinking about the specific environment and the data that you can extract from it. And also, I would say that you're doing a great job with color coding, because you are showing exactly, you're using color and graphics in a very smart way, and it's very clear the message that you're conveying. So well done for me.
Thank you.
Really, also for me, amazing project. Congratulations, girls. It's really cool. I like the last render, like a lot. And also very well presented. So thank you so much.
Thank you.
Thank you.
Yeah, good job, girls. I just wish we could see the last image, like even more, like more time in the presentation.
Yeah.
Like when you're talking, maybe in the beginning or in the final, like you can actually see everything coming together. The explanation is super clear, which I'm very super happy. So yeah, great job.
Thank you so much.
Thank you.
Yeah, I would also say that I'm very happy that you managed to create the story. It's much better now. I think your project is very strong, very cohesive as well. Basically, I have the same comments, but because I'm working with you every day, I think you should by now, let's say, figured out your style of the project and your vision and your story. And I think that now something happened, and at times you're insecure in what direction to go, and you do some type of changes last minute. For me, that's a little bit of a minus, and I think you should be more self-secure in what you're doing, because you're very good, both of you, and I think we should also see that. I think you both know what I mean. For the rest, thank you. The project is great.
Yeah, okay, thank you, Ada. Yeah, we know.
Thank you. Yeah.
Okay. Anyone else? Comment?
I'd like to say a few words. Kirill, if you want to.
Oh, yeah. Sorry.
Yeah,
for
we have, let's say,
a little
2
bit
more
of silence.
minutes for comments. So.
Oh, yeah. It's great. We have time police here. Anyhow, great project, really. Thanks for sharing, and it's been a pleasure working with you on that. I really love how you took this raw, cold kind of data, that is very scientific and data-driven, but at the same time, it's concentrated on human purpose. So that makes it, definitely brings life into that. And I love, how analog it is, even though it's quite digital. I don't know how to say it better, but yeah, great job. And there is some beauty in it. It's very obvious.
Thank you.
Thank you.
Thanks again, and keep it up.
Yeah, I wanted to congratulate you as well, because you worked with a lot of types of data and you managed to pull it all together in a cohesive storyline, and it shows on the project. The only thing that I would say about your project, the only feedback I would give you is basically in the last image, it seems a little bit like the different logics seem to be integrated, but I think they could use a bit more refining, especially with the public spaces and how they integrate with the other parts. But all in all, I think that considering how many types of data and how intricate and how complex your project is, I think you managed to do a great job. And congratulations. I know from working with you how much work you've put into this and how much effort. So yeah, very good project. Congratulations on this. And if you can yeah, have some time to integrate just a little bit more, like the different elements between themselves, that would be amazing. Other than that, great project and congratulations.
Thank you. We'll take that into consideration. Yeah, we should integrate it better.
Yes.
Thank you for the comments. I just want to add this, please feel free to add any comments, because the students have a third semester, which they're going to compile all the work from all chapters. So if there is something that you see, an opportunity for improvement, that's a great comment. Thank you, Kirill and Madeline.
Oh, well, that's...
And everyone else, of course.
If I can have one more thing, it's I guess this is something that everybody should remember, and well, this is something that I saw in your process, that sometimes you focus too much on the technological part of your project, while during the design, it's well, it's common knowledge. I mean, of course, the design is not bounded as much as technical kind of endeavors, but what you could do, and would definitely be would be very beneficial for you, is that you can start in the very beginning of the project. You can start in the big scale, and then as the layers of abstraction get closer and closer to the actual technical problem, only then you concentrate on those. So kind of start with a big picture, and then try to in a parallel manner find all the solutions to the questions that you dig in and find on the way. That would definitely help.
Yeah, thank you for, yeah, I'll keep that in mind.
Yeah, and the same with programming, right? You remember, we've been talking about that you start by drawing your problem, describing it to yourself in your natural language, and only then you can kind of translate it as a technical problem in a more meaningful way.
Yeah, the breaking down definitely helped. Yeah.
Yeah, but you did a great job. So I'm absolutely sure that you won't have any problems with that in the future.
Yes, thank you. Yeah.
Thank you. All right, let's move on to Team A3. Amon and Anthony.
Hello.
Hello. Oh, nice.
Can I share my screen? All good? You can see it?
Yes.
All right, great. Hello, everyone. Thank you for being here today. We will be presenting Chapter 5 of our Codex Recreo, Cosmogony. I am Anthony, and Aman will be joining us shortly. Codex Recreo is a simulation of a parallel world where the main element of life is a symbiote. Similar to carbon, this symbiote spurs life to a civilization made up of 4 classes: foragers, which track and collect, evolve into an agronomist, which grow and multiply, followed by an alchemist, which fuses and optimizes, reaching ephemeral stage, which builds and expands. In prosthesis, we focused on the first 2 classes, given their need to extract the most resources out of the environment around them. In corpuscle, we wanted to showcase the harmony that was necessary for this ecosystem of life, where the structure evolved with the correlating stages of evolution. For amalgamation, we take this synergy one step further, highlighting the importance of organic expansion throughout a self-sufficient ecosystem. In kinesis, our main goal was to showcase the importance of teleportation and how it further develops the colony's public networks, connecting colonies for exchange of resources, and the private network elevated vertically. The cosmogony of this parallel world replicates the pattern of subdivision we have maintained through the previous chapters. Our main intention was to connect multiple metro cities of high symbiotic densities with one another using various methods. The influence of these networks is relative to the 4 main classes of the simulation. As we progress into the areas of symbiotic fields, we experience more void and negative spaces, making way for more connections. Our inspiration comes from the way the universe expands and contracts at infinite levels of subdivisions, be it the neural pathways in the human brain and the cosmic routes between galactic formations and planetary systems. Having a clear idea of the rules and conditions, we began our exploration with 2 main approaches using nuclei and grasshopper. The food approach, representing the symbiote resources, helped us develop the metro cities. Connecting these clusters, we use the topographic-based aggregation and vector fields, elevations, and symbiotic irrigation.
Okay, so now we'll be discussing on how we were able to fuse this and create a logic of how we were able to create the network. So the first one, we took the terrain context, and also we also took the map of the amalgamation, which we had done in the previous chapter. So this map is based on the symbiotic erosions as well as the amalgamation pattern that we had. So we infused this with the height field of the terrain, and we were able to extract different sorts of layers. The first one is the circulation network, which is all around the context, and the second one is the pattern distribution, which is solely used for land boundaries which we have on the context. And the last one, you can see how it looks when it's fused together. This one, you can see some of the shots that we produced while we projected it into like 3-dimensional space and how all these networks look. Next, we were able to extract all the layers and show it in an axo diagram. So first we have the terrain, we have the height fields, and then also we also took a schematic of all the hot zones that we wanted to have in the entire context. And from that, we were able to extract 5 different layers, the first one being the boundaries, and then the second one being the metropolis, which is the main hot zone, which has embedded structures around it. And also, we were also able to have some public spaces. We have 4 to 5 different public spaces in our entire network, and also which is all connected through the road network. So the next one we discuss about how we were able to form the neighborhood extractions. So what we did is we took the corpuscle silhouette. We were able to create an amalgamation silhouette from that, and based on that, we were able to create 5 more different units, and we aggregated them.
Sorry,
by
you have
the use
1
of
minute,
WAS.
so please hurry.
Okay, yeah. So we were able to aggregate them, and based on the densities formed, we were able to differentiate them between clusters and metropolis. And these are some of the zoom-ins that you can see for our network. So these zoom-ins are based on all the neighborhoods that we have in the context. And finally, you can see the entire base map, which should be this one, yeah. And here you can see that we have a whole collection of different neighborhoods and clusters, and they're all connected through a main road network, and also some public spaces which are embedded around the entire system. Thank you.
Thank you. So, any comments? I
Thank you so much.
Yeah.
Guys, it's a really amazing project. Very interesting approach from the beginning, and really beautiful results. Also, the final render is really beautiful. Also, I like the colors a lot, the color code. So, really well done. Congratulations.
Thank you.
And also very well connected with the previous chapters, like everything is one whole. And I can't wait to see the final presentation and all chapters together.
Us too. Thank you.
Yeah, I have the same good comments for the projects. Maybe I just wish the public spaces to be more defined in the system. And yeah, you did a really good job on the network. It really shows the 3 different systems that you use. And yeah, great work.
Thank you.
I really liked your story, and well, especially Anton, I really like to hear you talking. So that also did
Thanks,
part. Yeah, it was great to work with you guys, and I really enjoyed looking at how you take that idea with the fungi that actually can flourish, can actually bring life to something that is dead, and that you incorporate that kind of philosophy of technology of the fungi into your project, and how you've actually made it into something artistic. Because I don't only see the function here. I really enjoy seeing a lot. Something that Severino also said, that the color coding is great, but also the deepness of the image does the job, does a really good job, and it has that depth, and yeah, it's just great work. Thank you so much.
Thank you, Kareem. Appreciate the help you've given us, also insights.
Sure. It was a pleasure. Thank you very much.
Congratulations, guys. Great presentation skills. Also great aesthetics. And I really love the way that your networks, like from an aesthetic point of view, like are really well combined with the amalgamation and the rest of your projects. So like you managed to do, like, to be consistent with the aesthetics in this chapter as well. And yeah, I mean the exploded axonometry map is really good. The final map is really good. The color coding, the depth, the way like you managed to like combine everything, even though you have so many layers. Like, great job. I really enjoy it. Like, very
appreciate
good.
it.
Thank you.
Thank you. Yeah, thank you. Appreciate the insights as well that you've given us.
It's been great working with you.
Thank you. Likewise.
It definitely shows that it was a great collab. Thank you, guys. Amazing work, cohesive from start to end. The only thing that I would say is that the axon, definitely, it's really telling a story. It's very clear. The final image, it's stunning, beautiful work, depth, everything that everyone basically just pointed out. But I do think that there is an opportunity maybe for the public spaces again. I think that in other chapters we talk about these public spaces too. Like they need their space, they need a little bit of just an opportunity to breathe and to be a little bit more dominant. Right, like as they are in a real space and city. Just keep this in mind. It's a visualization thing. It's not, like you don't need to redo any of the work. But yeah, great job. Thank you.
Thank you so much.
Thank you, Pavlina. Thank you. Appreciate it. Yeah.
Yeah. I think today I'll just point out things that could be better, so we don't waste too much time.
Yeah.
Okay, yes, great job, really very nice project, but I think for your team it's very important to, at least that's my personal point of view on a little bit on having a clearer image, because you tend to overlay too many details on top of each other. And for me, the image is a little bit too busy. It has a depth, but for me, it's a little bit flat busy, so to say. I mean, it's great, everything is great, but there are sometimes too many things happening on top of each other, and for me, it's not clear what is what, and maybe that's the whole point of it, but I'm just pointing out, in case it's not, that maybe it needs some more work.
Thank you, Ada. Yeah. Yeah.
It's the vibe of the project, Ada.
I think just the fact that we both want to show a lot of stuff, and there's the terrain that has to be put, and I think the chapter already has a lot going on. But yeah, I agree.
Yeah, but that's the art. How to make it.
No, I agree. We need that void in some places. We've spoken about it before, and hopefully we'll be able to tackle that with the final stuff.
Yeah, I think it was like basically it's here. It's also the amalgamations that make it a lot more complicated. So yeah, but of course that's just probably a visual representation more than anything else.
Okay. Yeah.
All right.
Yeah, because also the differentiation of the clusters, right? Like you have two types, actually 5 different types, like they're not so easily visible. Yes, when you zoom in, but they're like ghosted, right? So yeah, I think that there is just some room to see like how to interpret all this graphically a little bit more towards the end.
Agree.
Amazing. Yeah. Thank you, guys.
Thank you.
Thank you.
You definitely can do that. I mean, just from the look of how the graphics actually, look in the final product, you are totally capable of doing that, creating that visual hierarchy there.
Yeah, we need to work on it.
Maybe maybe it's more about asking yourself a question. Okay, what's important? What is the most important?
See here?
Yeah. Because well, you're so good at making it beautiful. You should be very good at also highlighting the important stuff. So yeah.
Yes, yes.
Yeah, the hierarchy. Thank you so much, everyone. Appreciate it.
Thank you. It's been a pleasure.
Thank you so much.
Yes, everyone, you also have comments from Mike in the chat.
Yeah, I was just reading that.
Yes. All right, thank you.
Thank you. Bye-bye.
Team A10, Diksha.
Hello.
Hello.
Hi,
5 minutes, yeah?
Yeah. Hi, everyone. I'm Diksha. My project is Exoenias. I started with the hypothesis that curiosity and adaptability is the secret to survival, and that these qualities are 2 of the most important characteristics of the human being's nature. I believe that due to mankind's inherently curious nature, we get bored easily and often tend to seek new experiences. This project is set at least 200 years in the future, a civilization of curious people who have already experienced all that Earth has to offer. The civilization consists of highly intelligent innovators who seek unique experiences. They intend to see the world around them in as many different ways as possible. In Chapter 1, the prostheses enable the user to perceive the world around them in their own unique way by manipulating their senses. Chapter 2 had a fully sustaining spaceship built for long-term travel. In Chapter 3, the spaceship came apart and formed units for colony aggregation. For Chapter 4, the specific concept was curious critters. I took inspiration from two famously intelligent and curious beings, the octopus and the crab, to design an on-ground unmanned vehicle whose sole purpose was to explore the planet, and an airborne vehicle that could switch between being public transport and private transport. Finally, for this chapter, I started by thinking how a world would be if curiosity purely drove our exploration of the universe. Curiosity exists where there is information, and information is abundant in the cosmos. I wanted to visualize curiosity as data through the passage of time. I started by exploring the clustering of the amalgamation colonies through the WASP plugin. I then began studying emergence and emergent behavior, and decided to explore the logic of cellular automata as a way to navigate this planet. There are various types. Types of logic in cellular automata, and I chose Conway's Game of Life. The simulation has extremely simple rules that determine the behavior of the agents in the simulation, and is the embodiment of complexity from simplicity and of emergence visualized. It is a study of how elaborate patterns and behaviors can emerge from very simple rules. There are three rules in Game of Life. A dead cell with exactly 3 live neighbors becomes a live cell. A live cell with 2 or 3 live neighbors stays alive, and in all other cases, a cell dies or remains dead. I started with here's a brief overview into some of the results that I was able to produce in the exploration, and I started with simple polygons as input to determine the starting conditions, and I then moved on to mathematical curves, which are basically just visual representations of equations. What I was looking for in these patterns was something that made sense visually. I was looking for a certain density. I was looking for inspiration on how I could zone my design as well. And then I extracted a voxel field from the chosen pattern, and this acted as the base for the nuclei simulation. The primary network is the one connecting a cluster of colonies to another. The secondary connects various hubs of the primary network. The tertiary network connects intermediary points and creates possible points of interest along the way. The networks are also layered vertically following the aggregation of the amalgamation design, and there has been an attempt to simulate depth by utilizing line widths and deeper shades. The networks overlaid together show the passage of time. This is the pattern I ended up getting inspired from the curved quadratics of Hippias and its generation 60. I visualize these as the cluster zones and these as the public zones. And this is how they are layered together. And finally, being an architect, I couldn't resist trying to visualize the spatial quality of the simulation as a physical form. And that's about it. Thank you.
Thank you, Diksha. I would like to just say one thing contrary, not what's wrong with your work, but that you managed to this time really make it and make something very interesting and unique. Whatever it is, basically it's something that you only have and you own it, and good job.
Yeah, I agree. Definitely, you've stepped it up here, and you really went into creating your own logic and the clusters and how exactly like this comes to life. What I would like to see is some work maybe on the final map in order just like to clarify some of the work, right? Like to make it like a little bit more clear of what is where. And yeah, and I think also that the color codes don't work very much in your favor in this situation. It looks like a blur, basically. Like
yeah, I actually added, I wanted to kind of show motion somehow. So I kind of added a motion blur to it. So that's...
I don't know. It's more clear when you zoom on it. Yeah, now we see all the networks.
Yeah. I do think that there should be like some more work and refinement of this map. However, but yes, now it's a little bit more clear on how everything is coming together. Check a little bit again, like with ColorMind also, like to see the palette. But other than that, like I think that you've done a good job, like in the cohesiveness of the project and in the uniqueness of it. Just, you know, like look into this map and see like how you can improve.
Thank you.
Well, you've chosen a very complex and very important kind of philosophy for that. I mean, I was so amazed by you choosing the curiosity thing because, you know, it's very psychological, it's very human, and it's very very closely tied to the notion of intelligence in total. And I mean, this is a very, very complex concept, very beautiful and important. But in your project, I feel like there's not enough. Like, you know, that it should be developed a little bit further because well, you've been using the game of life, you've been using some algorithms there, but it doesn't seem to go to make that next step to go into the realm of something resembling intelligence. And well, once again, it's very complex, so there's no wonder that you probably did not have enough time for that, and so on and so forth. But since, you know, your project will be developed later on, as far as I understand, right? That is an opportunity, and that is a great opportunity for you, you know, to broaden the topic, because it's great. And philosophically, it's so important, and it just makes sense very much. But once again, I feel like, you know, that there is a step, some more development that you could do and that you would like to do, actually. I mean, at least this is the way how it feels from your presentation, that there should be some more playfulness maybe in the game of life, because, you know, right now it's just a very basic kind of algorithm, and it definitely lacks that piece of your inspiration there, of your kind of design, right?
Yeah.
Great job. Anyway, it's a great job, and I really love that, you know, that you wanted to go and to also explore how the architecture of that would look like. And as an architect, you should see that right now it's not architecture, it's just basically extreme. Yeah, that it lacks that intelligence to become architecture. But this is a great step. I mean, it's a great prototype, I would say, in terms of project as a whole. And of course, you presented it as a finished project, and you did a great job here, I think. But something that Pavlina mentioned, that the gradient that you were trying to show as the time, as the work of time, this is something that also could be improved, because right now it just you don't see how those maps that are overlaid over each other. I mean, it's not readable, at least for me. How is that representing the time?
Mm-hmm.
But anyhow, really great idea, and conceptually, I love it. Yeah, thank you so much for that.
Thank you. Definitely was like jumping into a rabbit hole. There was just too much to explore with this logic. So it was a lot of fun.
Yeah, it's very complex, and I suggest, you know, before you start the next stage, just don't think about it for a while, so it goes a little bit deeper into your unconscious parts of the brain. So, you know, so you have some really creative new approach to that problem, because it is important and it is beautiful, and you definitely can do more with that.
Thank you.
So yeah, those are the words of encouragement, not critique, because it's really great. Yeah. Thank you so much.
Thank you. Thank you so much.
Diksha, I really love, like, from the beginning, the fact that you explored this idea of connecting two algorithms, the slime mold simulation and the game of life. But I agree with Kirill. It's such a complex thing to do that probably you would have needed a team of 4 in 2 weeks to actually pull it off in a great way. But considering the time limitation and the fact that you were exploring 2 different systems, I think it's good for now. But definitely this project is like a great promise, and I would like to see it further improved because it has so much potential. And I mean, like Kirill said, with the game of life, it has more expressions or more explicit, other ways of expressing it in a less generic way. And the same thing I would say with the slime mold as well, could be a bit more differentiated and more connected somehow to make things a little bit clearer. But still, like, I see it as a great promise and as a good start. And I would love to see it like taken that extra step further, because it's a good start and could really be like very, very special if you continue working on it. But yeah, great job so far. So congratulations.
Thank you. Thank you so much.
It's really a great project, Diksha. Congratulations. I agree that the approach is very interesting about the curiosity. I really like that. I wish you could zoom more during the presentation, especially on the map here, so we could see it better. And I agree about the colors. Maybe you should think about them, and so it will make the map more visible, more clear, etc. And yeah, I can wait to see the final presentation of all the chapters and see the whole story.
Thank you. Thank you so much.
Yeah, just keep up that idea because it's great.
Yes, thank you, everyone. Thank you, Diksha. Let's continue with team A9, Abdullah. Five minutes.
Good evening. The concept of I apologize for any background noise. I hope you all can hear me.
Yes, just continue.
Right. The team A09, we started off with the concept of energy transmutation, the idea of energy systems and how we can use those to enable various functions. And that began with our Chapter 1 prosthesis, in which we designed a system to enhance the human body and monitor functions of vital functions, and also developed a network of wires that could cover the entire body and stimulate muscles. And when we moved into Chapter 2, the idea of energy and how to manage and also isolate energy was crucial, and so we thought of developing something in harsh conditions, and so we developed a layered system in which our corpuscle could inhabit human beings, and it was based off of a polygonal shape structure in which various nodes would connect to each other. And in Chapter 3, the scope was expanded to planet Mars, specifically to a canyon, Valles Marineris, and this was chosen because of the presence of water, which was recently found under the surface, and so we selected this site and aggregated our parts across our field to achieve an aggregation which was suitable to the harsh terrain. And chapter 4 continued in kinesis with transportation networks, the public networks connecting the various nodes, public nodes to each other by a system of rails, and the private network, which consisted of a vehicle which had a system of on-ramps and off-ramps. Concerning chapter 5, which is the subject of this chapter, we look at our original site, which is the canyon of Valles Marineris on planet Mars, which is quite large. And the first thing that I did here was analyze the height of the map to achieve a domain in which the whitest parts are the lowest elevation, and use that as the basis for other maps which were later added. Map number 2 consists of a study done which shows the amount of water in the under the surface of our canyon, and this map was extracted and overlaid onto our original height map, and the color values were used using C# to achieve a map which showed just the levels of water based on the scale of the color map. This map was then blurred and then combined with our original height map to achieve the starting point for our network, which was created using nuclei. The network follows the areas where there's the lowest elevation. Sure. It follows the areas where we have the lowest elevation and the most water, and the parts, our aggregation. This this network is used to aggregate a series of parts, which from chapter 3 was used as the source of lines, and these were aggregated along with a third network of minerals, which from another study. This was similarly extracted. The color values, the red, blue, and green minerals seen in this map, were extracted, and different networks were grown, which were attracted to these networks. And
yes, okay, please wrap it up. Thank you.
And the combination of these networks allows us to grow our aggregation in the most ideal parts to achieve water and minerals in the area. And this is what it would look like. Thank you for your time.
Thank you very much. I just want to say right away that you're very good at big picture stuff. I say it that way, that you are you did a great job in terms of asking the good questions design wise, but on that lower scale, on that smaller scale per se, I think there is something more that you should do. For example, and even on the higher scale, it definitely lacks some kind of the hierarchy if we're talking about urban environment or something like that. And in that lower scale also, there is not enough diversity in terms of what is being used as public or private space, as basically space for people to inhabit. But at the same time, great job at the big picture of thinking about the energy in the first place, because it's essential to life, thinking about water, thinking about the resources that you can find in, and also thinking about how to survive in the conditions that are completely, well, that are a desert of death, basically, right? So once again, great questions, but you know, you should take it a bit further. So that's for one. And the second thing is, I guess your presentation, that is something that you should definitely think about the next time, because it's a bit haphazard. You had to jump from one point to another. You had also to jump in the end of the presentation to another part of the analysis. Well, you know, it's definitely more polite kind of for a presentation to start by explaining the analysis. Well, right after you explain the general idea. And you did that with the height map and so on. And I suggest that the analysis of the minerals and the one that you jumped onto later, that is something that just try tying it together. And once again, this is very similar to the things that we were talking about during the programming classes, right? That this is about clusterization of the data, about actually, well, declaring the data first and then working with it. And this is something that you could also incorporate in your presentation skills. But all in all, it's been a great pleasure, and I really love your idea. I just hope that you know that, yeah, don't give up and just push it further, because there is lots you can do with it. And thank you.
I agree with you, Kirill, 100% with all the comments actually you gave. So just to recap, Abdullah, you've done good progress. What you need to focus on is representation. You're an artist, you're working with color. Go back and rethink, make different options and see what really represents like what you're working with, right? Because it actually it's quite an important aspect, especially of this chapter, right? Like how exactly like you're representing the maps. Also the layering of the information, being there, being visible in one bigger map. It's one very important aspect of the project. And I would say the differentiation between any kind of public and private spaces with interweaved with the networks, right? And also presentation, very important. You need to be prepared to present and have a clear mind of how you're doing this. Thank you so much, though. Great progress.
I agree about almost everything, and I just again want to mention about the presentation. It's really important. So you should zoom more, and so we are able to see all the details. And maybe you had too much time talking about the previous chapters because you could tell the idea about them like with 1 or 2 sentences and have more time about the current chapter. So yeah, thank you so much, other than that, for the presentation and the project.
All right. Abdullah, I think you know my opinion. I don't have to go into detail, but in general, for me, it's not even about the presentation. It's that you just haven't done basically what the requirements were to put everything together. You are, if you go to the image above to the right, this zoomed in detail. So we see that you can, if you want to, but for some reason you didn't. So I don't understand, like, and I mean, we can improve this and work on it for the next several weeks after the holidays. And we showed you that, but for that you have to be here, you have to communicate with me and the rest of the team, and you have to be willing to just listen to these steps. That's it. Otherwise, everything that everyone else said, it's good. Everything is good. You just have to put it together and present it. Okay. Thank you.
I just wanted to add a little something, to sum it up. That the most important thing.
Shortly, please.
Yeah, very short. Just don't give up on that, because I've noticed while we were learning how to program that you are, you know how to concentrate, and you know how to concentrate on the detail, and you are very good at asking the right question, and that is essential to being a designer. So what I suggest you do is just you start with the questions and try to see what is wrong with your project all the time. This is the way to develop. And the the comments or critique that you just heard, treat it, the good designer treats critique as something beneficial, because those are kind of the holes in the system. And that is something that now, when you're aware of, you can fill with the solutions. So yeah, I'm absolutely sure that you're able to do that, and that you will benefit from it largely, tremendously. And yeah, just please do that. Please take the energy, that critique, and turn it into design. I'm absolutely sure that you can do that. And thank you very much. It's been a pleasure working with you.
Thank you, Kirill, for being so passionate and positive always and giving such good advice. But I just have to mention here, because now this is a small discussion, that the actual problem here is exactly this: going into the detail and into the technical part and into the questions. But sometimes in design, you have to take a step back and just play with it, just design, just be creative, and don't overthink on these details, because that's what we're lacking here. We're lacking this design, this playfulness, this a little bit more outside of the actual box. Because
yeah, that's why I wanted to mention, thinking about bigger picture there, that asking the right questions, from you'll remember learning how to draw. You have just to go back a bit to take a look at the big picture there. And yeah, I mean, it's not easy, and it's not something that you can measure. So there's a huge way ahead of you, that's for sure. But, just go with it, and it will be great.
Yes, definitely. Thank you, Abdullah.
Thank you all so much.
All right, Shitish, A9. Sorry, I don't hear you.
Yeah, because I didn't say anything.
Okay, so start, please.
Hi, I'm Kshitij, and my project is energy transmutations. Everything we see around us is energy in one form or another: nuclear, kinetic, gravitational potential, etc. A scientist named Kardashev developed a scale that stated that the advancement of a civilization is directly proportional to the amount of energy they consume. Based on this scale, humans have now achieved a Type 1 civilization status. In this Type 1, humans are an interplanetary species. They have successfully colonized Mars, and with the vast amount of energy at their disposal, they now have complete control over the climate and topography of the planet. With all this progress, the colonies of Mars are self-sufficient and have declared independence from Earth. They decided to build a place where the needs of the spirit and the care for progress would get precedence over the satisfaction of desires and passions, the seeking for pleasures and material enjoyments. It shall lay foundation of a new society, balanced, just, harmonious, and dynamic. This place shall steadily grow, and its residents continue to carry the same ideal and vision in their hearts and minds. The challenges are enormous and daring. When this dream touches you, don't hesitate to join us. Valles Marineris was chosen as the ideal location for the first neighborhood prototype. The site is that of the size of the continental US. The image shows the comparison of Grand Canyon with Valles Marineris. The site was chosen because there were instances of water found in the valleys, And due to the high temperature at the equator of Mars, they get easily formed into fogs due to high increased radiations. To get a better idea of the scale, this is the height of the Himalayas, and this is the New York City in the side. A bodysuit was designed for muscle enhancement and longevity due to change in environment conditions. Having graphene layers.
As you're going to take all the time for previous work.
Yes. You have only 5 minutes altogether. Just wrap up and continue to not do this. Now we're back.
Corpuscle was made using local materials such as basalt. Using basalt, which was locally present on the site of Mars. Metals which were extracted from the site. The height, since the gravity on Mars is 1/3 of that on Earth, a cylindrical form was chosen due to high hoop stress and also combating the high wind speeds. This is the form of aggregation topology which was chosen, and there were public spaces later identified and proposed. This shows the aggregation studies in the form of a catalog in which the results were based on weights of drainage field, height above the site mesh, and the flat surface location. This is the high value of drainage field algorithm, and this is connecting for the flat surfaces. We get this iteration when we have higher values for height, and this is the optimized weight values of all 3 variables. A private network was designed with a single-seater vehicle. Aerodynamics were considered as there are high wind speeds in this location. A public vehicle was chosen which followed the which followed 5
1 minute.
Yeah.
You can use 4 minutes to talk about previous work, Shijis. Like, it's the 5th time we're doing this presentation. You know you need to go faster with the previous work. You have the opportunity to talk about it. You have a full 3rd semester to combine everything. I understand you've tried to make your story cohesive, and I applaud you for that, but you really need to focus on your task. 5 minutes, chapter 5. You have 1 minute to go for chapter 5.
Yeah. So various height maps were studied after identifying the 3 locations. Considering the height maps, the primary network was chosen to lessen the distances between the amalgamation clusters. This is the network map relationship with the terrain. Drainage data was extracted based on which the aggregation growth was developed. The amalgamation density spread after the formation of the primary network, which followed the drainage, was done using C#, and its proximity was controlled to the primary network. Snow simulation was done for identifying the standable surface, and based on the algorithm developed in C#, the density was controlled on the flat surfaces. After this, the data of the amalgamation and network map was extracted, and this acted as the food for the network, for the resource collection network map. As you can see, this image shows the relationship between the resource collection network map and the primary network map, in the proximity of which the amalgamation is grown. These are the different keys to identify the main map. Yeah. So there are 4 parts to it. As you can identify, this one is showing the relationship with the primary network.
Can you zoom in, please, so we can actually see it?
Can you point out your 5 types of clusters and all deliverables that like need to also be part of your story and also part of the map?
Yeah, so these were the patterns which were forming due to these variables, right? So it had to follow a drainage algorithm. That's why the data was extracted from this map, and the amalgamation was placed. But after making the primary network with the height
I
map,
don't understand. Where are they? Are they the blue things that you have on the map?
Yeah, they're very small in scale. He needs to zoom in.
Okay.
That's why he divided it in 4. Shitish, please explain your project.
You wasted so much time explaining previous work that you don't, and you can explain this part. Oh. Can you zoom in and explain what exactly is happening?
Okay.
You can't see anything, you understand that? Like from far away, everything looks exactly the same.
So the height map data was extracted, and the primary network using nuclei was developed. And after that, the drainage algorithm which was ran on the site, that data was extracted, and it was chosen as the location for aggregation. But since we had the primary network,
but you're putting your clusters on the drainage, right? What are you putting on the drainage? How are you using the drainage? That's what I'm trying to understand. Like, what is the relationship of the drainage and your clusters?
So these clusters, they are following the drainage.
Can you zoom into them? Because really it's one image in 10 different colors that we see from here. So zoom in so we can really understand like what's happening in this even more.
Okay. So the primary network which was formed above, in the proximity of that, the drain. Just give me a second.
Hey, thank you.
Okay. So this is the primary network based on the height maps. Okay. Now the drainage data was used to. Okay,
but the drainage, the height and the drainage, like they look exactly the same, just reversed, right?
No, the height, this is the height, and then there is more data to it.
Network map. Okay, that's the height. Okay.
Yeah, so this drainage is same as the previous aggregation. So it follows that field. But since I created a black and white map, so I could extract the data so that I can control the density around that network for the flat surfaces. So this was a snow simulation map, and as you can see here, this is like the 1/4 part of that image, and there is like increase in density. I could control the density along those networks and respecting the drainage.
And why are you using the data you're using? Why are you choosing the spaces you're using for your maps, right? Why do you care about the drainage? Why do you care about the snow?
Because of the snow, I thought like surfaces would be more flat, which I previously considered in the aggregation neighborhood. I considered 3 factors: height, drainage, and flat surfaces.
And you need a very clear diagram for that in order basically to be clear about your project. You have a project, you have an idea, but you just cannot convey it in any way. Basically, the presentation that you're doing, it's really, really on a very low level. It cannot be a presentation of 5th chapter. I do not know why you're not prepared. You need to focus on the work is there, but there is no adequate information around it. And also when you're asked, it's very difficult for you to focus and to answer the questions and to explain the work you've been doing. You need to always be ready for the elevator pitch. We've talked about this many times. You need to have a very clear idea of where you're going, what you're doing, and have that, you know, like ready to go if you have to pitch it to someone in a couple of minutes. That's my comment. I think you have a long way to go on your presentation skills, but you're definitely done a lot of work here in chapter 3, trying to improve. Also, I see improvement in your in the way that you're displaying the work. So you're definitely growing, but you do need to take some time and really put in the time into the presentation and see how you're going to convey the message to others.
Yeah, I agree with Pavlin. I think your work, this chapter is like the maybe the best overall in the 5 chapters, and that shows. But you need to like step up with the presentation because this is like half of your job is to present your project in the best way. It doesn't matter if it's like complex and it's super multi-layered. You cannot if you can't present it, it doesn't matter.
Just not to repeat what everybody else said, because those are very valid critiques of your work. Once again, the same thing. Try to use it for your benefit. Try to use that as well, basically the locations of the holes in the system that you build, and this is something that you can definitely fix. But I think what your problem is, well, from looking in abstract way, that everything is important, and you're focusing on everything in with the same amount because you're a very enthusiastic person. That's great. That is very great for you as a designer. But you have to build a hierarchy. Have to build a hierarchy there so that not everything has the same level of importance as everything else. So that's why you definitely were not able to actually incorporate all those things that are equally important to you into one project here, right? And yeah, I suggest you do that. You just build a hierarchy there. And in that chapter, you were supposed to show what is important. So basically that large area that is settled in some way, right? And but I believe you have great ideas, and your story begins in a very good way because you walk through this a lot of times, right? And this is something that, well, unfortunately, we don't have that much time, but I would love to listen to that more. But once again, hierarchy is something that will definitely let you design it in a more, will let you design in a more meaningful way and also present it. So once again, it just seems to me that you have the lack of hierarchy on a lot of levels in your design process and your presentation. And that is something that, well, but you're absolutely capable. Yeah, that's what I'm saying. And that I believe what is a bit appalling for the other tutors that that they see that you can do it, but you're not doing it. But once again, it's not a curse. It is something that you can definitely learn how to do. So yeah, it's encouragement.
Thank you. Thank you, everyone. Maybe Madeline. Yeah, if you want to.
Yeah. So, like feedback on the design. I think the slime mold is almost like, while exaggerating this, I mean exaggerating this, of course it's not like this, but it's almost like a Photoshop filter from the image you picked with the drainage. So it doesn't have like enough space to develop. It's too constrained to the initial image that you've done. I've given you this feedback before. But you have moments in which things, yes, exactly here, in which it starts becoming interesting. And like looking at these two maps that you're showing right now, to me, they seem like a lot more interesting than the final map where you try to overlay it with so many things that it just becomes a little bit hard to read. I mean, not a little bit, a lot, like very hard to read. But in these areas where it's quite clear, I mean, it's just like Kirill said with the hierarchy, you cannot solve everything in 2 weeks. So you have to choose your battles, and you show, like, for example, in these two maps, like you really show that you can do it. So yeah, it's like, I think you have all the ingredients, you have the work. It's just a question of like presenting it in a, and I think you're good with presentations, like you know how to talk. It's just that you were not time sensitive. It would probably take half an hour to listen to your whole presentation. but it's like, I mean, the way you present things, it's good. You just need to be time sensitive. And I believe that your project can be twice as good if you just focus on in the last map. If you focus on the things that you need to like on the big map, if you focus on the things that you need to like solve and show us like a clear image, or maybe if you have so many types of data that you analyze, maybe don't make a map with all the things one on top of the other, maybe make 2 maps or 3, I don't know. But it just seems like very like, I don't know what the colors represent, there's no legend, and it's a bit hard to read. But you have like the ingredients to do it. So it's just a question of like, how can you present it in a more structured way? That would be my feedback. But I think you like seeing a project. I'm especially like the last part that I haven't seen what you've done in the last week. I'm quite impressed. So yeah, congratulations for working hard on this. And I think you're a few more steps away from actually like nailing it the correct way. So you have the ingredients. So good luck. I think it will be okay. You also have the right guidance, so you can do it.
Thank you.
Thank you.
Thank you.
All right, let's move on to team A8, Just and Rasem. Okay, so 5 minutes, right?
All right.
All right.
Hello.
Do this.
Awesome. Yeah. Are we ready? Okay, yeah. Hello,
Yeah.
we are Assam and Joost from Group 8, and this is our Cosmogony design. Our story takes place in a world which is drastically changed through the effects of climate change and the depletion of natural resources. Most humans died because of these effects. However, a group of scientists have gathered in Moscow and developed new technologies and materials to aid human survival. The cosmogony design in the final form is the final form of a long list of objects, structures, and networks in this universe. From personal protection prostheses to living units, close-quarter networks, and finally a large-scale network, the design follows the idea of human improvement and the fulfillment of basic human needs based on Maslow's hierarchy of needs. They have in common to protect the users against the destroyed environment and improve the imagined group's life. The proposed design is closely tied into the environment, which is in this case the city center of Moscow. We defined main axes and places for amalgamation positioning and set up a flow field which should visualize different underlying flows through the city. These fields were guides for the final, more scattered and organic particle simulation, which created the final network. In various explorations, we were able to understand and regulate the simulation.
Okay, so the amalgamation clusters consist of multiple net-scale structures which are assembled from multiple similar corpuscle units. The cluster represents different functions useful and necessary for everyday life. The first and second cluster are living clusters where close-quarter living spaces and communal areas provide the main living centers for the group's members. The third cluster is visually the least impactful, but it has the most impact on the group's life, and here new research is being done and new technologies and materials emerge. The fourth cluster represents the culture and sports centers, which provide another important pillar of human basic needs. In this cluster, facilities which aid social interaction and self-actualization are situated. In the fourth cluster, health and care facilities are integrated with hospitality and physical and physiological therapy and gym. Finally, the biggest cluster are placed for firming which the growth of the group, the needs for food and grow and increasing areas food production are needed. Using advanced agriculture, vertical food is being growth.
The final cosmogony network ties in closely to the other elements which are guided by the city environment. The transition between the network scale happens on the circular outline of the network, of the close quarter network. In this final map, you can clearly see the different amalgamation clusters with their surrounding networks, which are set up for smaller scale vehicles or even movement on foot. Leaving the immediate radius of the structures, broader connections become visible with lighter connections, example here, to act as entry points to the network. Distinct straight axes allow for main connections between different parts of the network with higher speed movement. These axes here, right here. Thank you very much.
Thank you.
All right, comments. We have 5 minutes. Please keep them short and clear.
Well, then I'll start, I guess. I really like your project. It is very consistent, and I think you chose a good scale, you know, to represent, well, the good scale and the part of the terrain that you would like, that you actually chose to create your design on. I just wonder, you know, there is this notion of those amalgamations being kind of, it's like a snapshot of what happened at some point, but I thought, you know, from the map that you were generated, that you will see some, that you will show us some growth of those amalgamations and how they blend in together, for example, because right now they basically use the old city as a terrain in which they're trying to, well, manifest themselves, right? And it just looks a bit weird because they became like small satellite cities that have that are not trying to connect in any way. And also, you know, once again, I don't see any hierarchy there. But in general, you know, I like the story. I like that you were trying once again to conquer death in some sense, right? To inhabit some environment that was destroyed and made uninhabitable, and that you have a real process underlying this whole thing. But once again, I just don't see the hierarchy, and that is definitely my problem there, because as architectural urban kind of design, it is very important there to be, you know, that scale of importance, some kind of hierarchy for people to orient themselves in. And that is definitely the way to develop your project further, because once again, you kind of have a blueprint on which you can work further to actually make it be something more like a living environment. Also, of course, you can make the case that in the new society there are no such things as hierarchy and everything is equally important. But, well, as far as we as humans are concerned, there is no such thing as nature where everything has the same value as everything else.
That's true. Yes.
Yeah, but all in all, also visually, yeah, it looks very artistic. This is something that it grabs the eye pretty intensely. So once again, great job at taking algorithms and data and making art out of it. So I hate Moscow, but this is great. Like, you know, even with that bias that I have in the head of Moscow, I just, when I look at that, it looks beautiful. So thank you.
All right, thank you. Let's move on to the next comment.
Hi guys, do you hear me? Because
yes,
I think
now we do.
Oh, okay, perfect. So yeah, conquer death. I love that comment there. I would just want to emphasize, because you're so concrete also on what each cluster is, you need differentiation, right? Like they're your protagonists, they're very important, where they're placed, how they're placed, why they are where they are, but also the way that they look. Like it cannot be that farming looks like health and care and like culture and sports, right? If it's culture there, but you get the meaning. We were talking about this even in amalgamation. You're both like with an architectural background. Just think about like the different typologies you need in order to create like all these different things, right? Like I love that you have the differentiation, but you really need to go back and evaluate what does this structure mean. You can have the same language, right? Like when you're making master plans, when you're creating a little bit like more avant-garde, like, you know, like designs that are cohesive throughout the whole project, you can still do that with the shapes that you're working with, but there is differentiation in scale, in geometry, and that's at the end of the day the beauty of it. And I am lacking the definitely the layering of the map, right? Like there is just very flat the approach that you're taking. So you can think about like an additional layer or how to improve. But so far you've done a good job, but you have things to work on and improve in this chapter. Thank you, guys.
Thank you.
Yeah, I would like to just add very shortly that for me, this change that you did in dividing the clusters into different areas is not working at all, because that's not the future of, in general, of how cities develop. It's more of a mixed use than satellite usage. And if you do it the way you do it, then we need to know why. And also the one thing that I said, for me, it was very important to have differentiations in the layers of, however you call it, even if it's pedestrians versus transportation or whatever. I saw that you try to create some type of gradient, but it's absolutely not understandable for anybody outside of the project and me, basically, because, so that's why that's from me. Any other comments?
Yeah, I would say that like one thing that would have added hierarchy, like a very simple thing that we also discussed, but you haven't applied it, is like just emphasizing the axis, because basically you're drawing the axis first and then running the simulation. So you could have just used Photoshop for that. The axes are less visible than the secondary kind of trails. That's one. Another thing is like, do we really need those circles? I mean, your clusters are so organic, and I would say like maybe because I see that you've integrated the clusters in the transport network.
Yeah,
so
but sorry to interrupt, because that are also part of the public spaces, and that's why I was saying that they're not, it's not understandable. That's why they have these areas around these clusters.
All right. Well, I mean, it's for me personally, they're not very integrated like those circles. I don't see it like that. And I think I mean, we need some hierarchy, because like there's the network is so dense, and I mean, it's beautiful. It looks beautiful, but I think, you know, like with these kinds of ingredients, you could have done a lot more. So I hope that in the time that you have left, you would continue exploring it, because the kind of ingredients that you have are quite special. I just I would just love to see more explorations, more hierarchy, more integration, things like that. And also, with the clusters, they're not differentiated enough. I can't tell which one is which. Unless I look at the explanation. So I think, I mean, it's like you have the ingredients, you receive the feedback. It's a question of like, you know, working hard and implementing it. I feel like you could have done more, like a lot more with this project. But I mean, it's good, but it's just like, with these ingredients, you could definitely have done a lot more than this.
Okay.
So
Yeah.
hope that you will continue working on it because it has a lot of potential.
Mm-hmm.
Yeah, of course, every team will have the extra time to work on all these comments and improve their projects and make them even greater. Right?
For sure.
Okay, yay.
Nice. Thank you.
Thank you.
Thank you. Thank you. Thank you.
Team A7, Kyle and Ahmed.
Hello.
Hello.
Can you hear us okay?
Yes.
Great.
Okay. Do you hear me, guys?
You're good on.
Yes.
Yeah. Okay. So we start. Americans spend between 5 and 6 hours per day on their smartphones, and more than half of American children own a smartphone by the age of 11. This saturation of social media and physical disconnect will continue to shape the world we live in. The story of the emotional caricature explores a world where humans have reached the pinnacle of emotional disconnect and lack any ability to sense emotion. The story goes that a prosthetic is introduced in the market which focuses on transfer light directly into the retina to stimulate the vision system and reintroduce the body's sense of emotion. And as a human develops a new capacity to experience emotion, in turn new spaces emerge. The proposal starts from ground level with the habitat, which serves a small group who share an overall space divided into several units for both living and exploration. Floating above the habitat is the privation pod, which offers a personal space for experiencing the city through curated emotional lenses. Each neighborhood features distinct transportation hubs, which act as an anchor point for the area. From these hubs, inhabitants can travel along the private network upward toward the cluster of pods, or they can navigate the neighborhood at longer distance along the public networks.
Movement along the networks is achieved through the use of distinct vehicles. The public cable car travels along the network's physical infrastructure, providing scenic views along its way, and the private drone, which is capable of air travel through the city and configured to allow various options for docking. And hovering above the neighborhoods is a series of airships, which act as stops along the private network. These private stops also serve as additional meeting points for the neighborhood's inhabitants. As we began thinking about how these complex neighborhoods would come together at a larger scale, we first looked to other cities and examples of growth networks. It was important to consider the different properties of the city at various levels. The layout of each neighborhood at the smallest scale features an orthogonal arrangement of habitats, visually forming a deep void around each transportation hub, while the more fluid connection of neighborhoods was expected at the larger scale. The layout of the new city takes critical information from the old. The existing site map is first analyzed to identify critical resource locations. These are areas which act as the anchor points for development, defining the general growth direction of the new networks. An assessment of the existing city grid then identifies areas with space available for redevelopment. And then numerous trials were carried out to understand the balance between new and existing grid. Once crucial routes through the city were understood, routes were then categorized in terms of throughput and function. Here, the thickest, most dominant curves represent the largest scale of mobility, while the thinnest provide the more intimate movement from the existing city to the broader network. Neighborhoods are then developed along that network, and finally, an expansive park system is discovered connecting the adjacent neighborhoods and taking advantage of the enclosed voids within the primary network. Neighborhood definitions also vary depending on their layout, where the less expansive configurations allow for a single transportation hub, and the more expansive allow for multiple hubs within each network, within each neighborhood.
When we zoom out at the largest scale, we find the new evolutionary movement is becoming more connected with the old city and using it for new development. The old city got more abundant and lost its features. So its last function is to feed a new growth. Here, each part of the city is trying to reach its neighboring element for a stronger relation between the inhabitants. Each network serves a specific function. The main network, where the private vehicles take place on it for far distances, the secondary for shorter distance where the cable cars go travel through, and the third the thinnest network, which serves more as scavenger road to claim the resources. Each downtown is unique, depending on its location and its surrounding features. The larger the neighborhood, the more extensive the surrounding network is. The neighborhoods are ever-evolving, connecting either to one another or to the public parks. And over time, the public park system grows as it branches out from the neighborhoods, attracting and trying to itself connect throughout the city. Johanny Palasma writes, "The sensuous city, a reflection on a poetics of urban experience. The resulting approach clearly indicates that the formation of the ideal city begins with the use of the inhabitant itself." The emotional caricature.
Thank you.
Thank you.
Thank you.
Exactly 5 minutes. That was
Well
great.
done.
Yeah, to the point.
Very well done.
Thank you.
Yes. Presentation, the work you've done in this chapter, you guys are definitely killing it. Also, all this thought that you have put in your system, the elements that you have in the system, the way that you transition from one space to another, like I think, and also the outcome is beautiful, right? Like I think that you have all ingredients in your project. So congrats from me, really well done.
Thank you, Pavlina. Appreciate that.
Thank you.
I also love how you guys like really like they came into the program and really like grew together, right? Like, and you're really like killing it, and I'm really happy to see that.
Thank you.
It's a really amazing project, guys. Very well done. Also from the previous chapters, the connections and everything, it's really amazing. This final map is really clear, interesting, understandable. So congratulations also on me. Really nice.
Thank you, Svetlina.
Thank you. Thank you.
I love your work, and yeah, once again, presentation really great. And also from the very beginning, I was impressed that you chose such a psychological topic there. I mean, those are the complex topics, and it's a great challenge. I think, well, you have everything that is needed in terms of urban design, because you have the hierarchy of values there, you have the infrastructure, and also I was very pleased that you emphasized on the greenery there, that you know that it exists and that it also serves as a connector between the neighborhoods there. I guess, you know, if I was, you know, if I was to critique you in any way there, it would be that, you know, maybe there is sometimes it just seems that the approach is too algorithmic. Because, for example, in the northern part of the city, you can see the two kind of clusters that are that don't seem to be connected to the other system, right? Mm-hmm. So the whole. But this is just, you know, this is just an observation, because I'm just trying to critique you with something. Well, you know, just so I can help you with your project in some meaningful way. But all in all, yes, it's great. And thank you very much. Thank you very much for going and working with that topic. And yeah, good luck. I hope
you, and thank you for your help. Appreciate it.
It was a pleasure. It was a huge pleasure.
Thank you.
Yeah, great job, guys. Maybe just like one or two things. The district neighborhood network. Maybe you can have like one more thickness. Maybe the lines that are near the main, your main, like blue network can be a little bit stronger. Mm-hmm. So we have like 3 different thicknesses, and that would add a little bit more depth to the project. And yeah, maybe also where the blue lines actually meet, like one of these parts of you cannot see cursor. Yeah, the parts that are that the lines connect like 4 or 5 lines. Maybe here you can have like a more, like the same public space that you already have over here.
Mm-hmm. Yeah, yeah.
It's actually where the real public space is.
Yeah. Okay.
Yeah, That's very nice.
But also the emotional caricature, that just sounds so well. I mean, it's very well put. And I guess, you know, yeah, just please go and do something more with that, because it's very interesting topic. Sorry for talking again. It's just, yeah, philosophically, it's very, very interesting.
Yes, absolutely. Thank you guys. I can also add that I think your team grew immensely. I'm absolutely satisfied and happy with your work and with your growth, also aesthetically and visually, conceptually and everything. And it just gets better and better. And you really also manage to work on your soft skills and time management, and you're always on time. And that's insanely great for the type of masters we are in, because, you know, everyone can do everything if they have endless amount of time, right? But we don't. So
yeah, thank you, Ada.
Appreciate that comment.
All right, thank you.
Thanks again, everybody.
Thank you, guys.
Thank you. Keep it up.
Team A5, Kirk.
Hi.
Hi.
I'm going to share my screen.
Yes, please.
Hi. My name is Kirk. The name of the project is Feminauts. So to start off, the theory starts off on the definition of a supreme mind, which is the ability to sort of download all information in the universe. So prosthesis respond by the modification of the body in reference to human animal anatomy to enhance the body beyond human capabilities. Corpuscle is a factory unit that stores animal body names to act as reference and for the modification of the android body. So in order to sustain the supreme body and supreme mind, amalgamation is a power plant that extract heat energy from the volcano to power the body, mind, and the factory units. And kinesis as a transportation is a transportation vehicle that explores the volcano and underground for greater resources. So Cosmogony is a network in Iceland, being a land of ice and fire, to satisfy certain goals, right? So in order to counterpoint the heat, the nature of the intensity of the heat, water and cooling is required to sort of counterpoint the intensity of the heat, right? So the key point you take away is the goal, right? It's heat and water, right? The two main goals. So given the Iceland being identity located between the tectonic plate, which is prone to geothermal activities, and the fact that it's located at the upper latitude, contributes towards the identity of the land of ice and fire. So this land of ice and fire mirrors the goal of water and cooling, right? So if you look at the map of the Iceland, we can sort of study the map and look at the map. We can sort of categorize the resources provided by the land in terms of what provides to fire and heating, what provides water and cooling, right? And then we can extract relevant resources information with them and then simplify them, right? Because the amalgamation structure grows on a volcano, so we can sort of define the potential of each volcano depending on the surrounding context, right? Like for example, like the volcano is closer to an area of higher precipitation, then it's closer to its goal of water and cooling, right? The same logic can be said for a sun, the same logic can be said for heat, right? So depending on how many conditions satisfied, we can dictate its fitness value, right? So for example, a plant requires sun, water, nutrient for the growth, right? The more conditions you satisfy, the greater its capacity to influence, grow, and dominate the landscape, right? The same logic is applied, right? So each volcano is sort of measured semi-randomly, and we can sort of define its fitness value. And this fitness value is interpreted as the strength of the field, right? From lowest to highest, and the field is unified through its crack and location of volcano, and in turn contributing to visual interest of pattern and hierarchy and scale. And we look at this circular area. The area is an area of dominance, right? Because First off, is the intersection between the crack. Secondly, it consists of 3 volcanoes that's 93% thickness value, right? So it naturally causes a lot of tension. So in order to form the network between the resources of the land, nuclear is studied, the software nuclear by Madeline is studied, right? So we start off by controlling one variable and see how it influences the usual pattern, right? We influence the speed, we see the density line, we can change the sensor angle to get cloudy lines, etc. And then we can move up into higher complexity, combining 2 conditions. And then we can see that a lot of time they are children of the parent pattern, right? For example, speed and sensor distance. Sensor distance leads to this Voronoi patchy thing. Speed leads to this density line thing, right? So the outcome is a denser Voronoi patchy thing, right? But some patterns is rather destructive, as in like rotation angle lends to less dense, and speed lends to greater density, right? So the outcome of them is become balanced, right? So the destructive relationship. And then sometimes the patterns are unpredictable, perhaps due to my incomplete understanding. And then some conditions overriding, for example, food. No matter how you combine food is always expressed as static point, right? So from these studies, we understand how to use nuclei to form network and form pattern. So now we know from narrative, we establish the goal of heat and cooling. And from the site studies, we know what and where is provided in the land, right? And from the nuclear studies, we know how to form a network and how to form pattern, right? So the goal is to combine the nuclear plugin with the information of the map as to gain the resources of the land to achieve the goals of the narrative, right? So the logic is I have a crack, which is the red line. I have a spiral field pattern, and then I have a river finger stretching from the boundary and the mountain. So the logic is also from simple to complex. We sort of form studies and formations, like between the volcano and the crack, controlling the condition one by one. And you can see like each of them is expressed differently. Volcano is expressed by the point of view, and the river is expressed by this sort of finger-like length. And then the heat flow is expressed by density, right? And then they're combined.
1 minute, please.
Okay. So they are combined to sort of unify them, right? Blah blah blah. 2 to 3, 3 to 4, 4 to 5 conditions, and then you combine them support, right? So this is the best I could get. So you can see like it has qualities of bit of everything. So you have the field and the points to establish a volcano, and then we can sort of see the crack on the implied axis, and then we can see hints of the river from the length of it, right? And then you can see the density of heat flow from this sort of wiggly texture. So in terms of the massing, is that from the amalgamation is that those who face in the light is horizontally stretched, those who's in the shade is vertically stretched, right? So there's a logic from shade to vertical, like to horizontal, right? So this logic is then sort of by using the sunshade map, and then we turn them into an image sample, and then stretch accordingly, and also in reference to the field, right? So we can get this pattern that's derived from the field and from the sunshade, right? So this is the final image of the map. Yeah, I'm done.
Thank you, Kirk. Can you zoom in a little bit? All right.
Even more, please. It's a little bit difficult to see. Yeah.
Can I start?
Yes.
Okay, thank you.
I'll time you. 1.5 minutes.
Okay, go. Loved your studies. Really great data analysis and thinking about and actually, integrating it later on. I remember your process quite well. You did great in that phase. But and actually, I think that you provided a very sufficient and very exhausting kind of blueprint to the architecture that you can later on embed in there, because what I personally lack in your project right now is the actual architecture there, because it has everything, but you did not distribute the actual meaning of those settlements there, right? They're in the right place, and you have reason to put them there. They are distributed very well. So basically, it's the purpose. Yeah, they're in the right place. You have the reason for them to be in this place. You did, you exhausted, the way that you use the terrain, and and you know how you use it. So the rivers, the volcanoes, the water, the land, great, but there is no hierarchy of meaning in the settlements that you in your amalgamations, and how I mean, you have the placement, but you don't have the meaning. For example, you know which part of those amalgamations do what for the society, right? So that is not clear. So I think, you know, just like that one step, because you basically have it there, right? You just need to kind of show that and make those decisions that you could obviously in part derive from your great studies of the natural terrain there. And yeah, I mean, bravo, great job in terms of analysis and in terms of providing that structure. But once again, it's like that puzzle that you have for children, that you have the shapes and now you have to color those, right? So this is something like that. There is no meaning hierarchy in the architecture, but all in all, great job. Yeah, I really like it. And it's beautiful also. So that is also, I don't know how you guys do that, but the things you provide, the things you produce are really beautiful. Did I make it in time?
Yes, 2.5 minutes, so it's in time. Yeah, I just will add one more sentence. I agree with you more or less. I just want to tell you, Kirk, that you really did amazing progress visually, conceptually. Everything is there. It's just the one last push after the holidays and the labs that you have to really focus on the final designs, where you start to aggregate or amalgamate or whatever it is something, because then this is just the one thing that needs this extra tweaking that you are now doing onto everything else. And I'm just wondering, when did you have time to draw these fishes? Are they sharks or what? It's a joke.
They're so big.
Yeah, they're. I don't want to be there.
Yeah, but it also emphasizes the resource. You know, this is great because it works as there's well, image that tells you the information about what resource do you have there, right? This is fishing, obviously. This can provide people with food, so great. And great joke, Ada. Also, you know, I'm so used to being so bossy, and now you're.
Thank you, Kirill. Do you want to take over? I'm gonna.
No, sorry. No.
Take coffee. I think you're doing great as well. No, seriously, nice. It's nice to laugh. Thank you, Kirk. So, more comments?
Yeah, I'm loving the work, Kirk. I'm happy to see everything coming together. As Ada mentioned, and Kirill, I agree with their comments. I would like to see a little bit of more of the hierarchy of the amalgamation, how actually this will actually impact also like what you're doing here, right? Like when you go back to this chapter and revise some of the work. But all in all, great progress. Thank you so much, and keep going.
Thank you. Yeah, I would like to, I agree with Pavlina, you have a great progress, but you also need to do a last push with the amalgamation. Other than that, it's your project is maybe one of the most scientific ones in terms of how you take all that data, how you analyze the behavior of the slime mold, how you put it all together, how everything is so logical, and we can follow the storyline in a in a clear way. So I think, and also the amount of work you've done, a huge amount of work, and I'm very happy with your project, and I think this one last push with the amalgamation, and also make it smaller, make it denser, make it zoom in, these things. It's just that you ran out of time at the end, considering how much work you've done. But if you do this last push with that, I think, it's a really good project, and I want to congratulate you on all the work and how clear it is, how things connect. I'm pretty happy with it. So congrats, Kirk.
Thank you, Melody.
Yes. Thank you. More comments, or should we? Yeah. All right. Then.
Yeah. One more thing, just to clarify what I meant, because Michael wrote a comment for the previous group, and he used the word function. So that is actually what I meant there. That you lack the emphasis on the functions. What? Yeah. Just to make it clear.
Yeah. I don't want.
You know, like color and stuff. Yeah.
Yeah.
Great job. Great job. Yeah.
Thank you. Thank you, everyone. Okay. Team A2.
Hello. Hello.
Hello.
Okay. Deterioration, extinction of plant and animal species, planetary instability. In 2099, would we need another Earth? Ladies and gentlemen, speakers, admin, guests, and fellow students, we, Alab and Ali, proudly present Exuvius Volume 5, The Anthro-Cyborg Metamorphosis, a catalyst towards growth, the Exuvian ecosystem. In just 50 years, we would have managed to move ourselves out of the state that we were in the past 10,000 years. We have now moved from the Holocene to the Anthropocene, where humans are the primary drivers of change. We are already approaching tipping points threatening the planet's stability and triggering an irreversible decay. Could we reverse this decay? Is it possible to induce decay as a catalyst for growth? We investigate the systems of nature where insects and animals undergo molting to grow, to evolve, to adapt. We anticipate and we program the advancement of technology and the harmony of man and machine and design a resilient system of symbiosis. We introduce a fungal growth system with varying fungal species that either decompose, enrich, sustain, or defend our ecosystem. With the ability of fungi to metabolize harmful substances and generate fertile soil, we catalyze a single spore to convert a desolate land into an oasis of life. From that oasis, we expand. We follow the journey of the Exuvian man, initially deployed in a bushfire-stricken cliff in Australia's central region. He serves as a scout and scientist equipped with a suit supporting molting abilities which promote adaptability and autonomy to sustain himself. Together with the Exuvian scrambler pod containing all his necessities and building materials, he sets off to find uninhabitable areas suitable for rehabilitation. Once established, he begins his day-to-day routine gathering surrounding organic material to convert into reusable sources for growing the first habitat, the Exuvian oasis seed. As the conditions stabilize, it becomes necessary to invite other citizens and families to form a colony. As this grows computationally in size and population, a community is created, the Exuvian organism, a highly adaptive and resilient colony that functions to create livable cities from desolate topologies. As a fully sustainable settlement, it is a self-assembling prototype that adapts to any terrain, autonomous in resources, diverse and resilient to inhospitable conditions. At around a decade of germination, the colony has matured. This period has brought technological advancement to the civilization, adding transport networks and vehicles, the Exuvian Exolink transport system and Exofuse vehicular series. It is a highly forward and sustainable network system that functions to provide linkages within and beyond the colony.
For the final phase of our planetary bioremediation system, we present the Exuvian ecosystem, which is a generative master plan for our envisioned biomes. We target a multitude of critical areas from radioactive meltdowns, oil spills, savannas, and our prototype, a country razed with bushfires. True to our project's fungal concept, it is in our system's intelligence to sporulate through aerial currents and populate these different zones. For each zone, the system behaves differently. For each zone, a different character and a different set of species as catalysts. We prototyped our system as a macroorganism inspired from the slime mold. As a slime mold, it is a collective of single-celled organisms. As a whole, they are an intelligent, complex structure. Our ecosystem is controlled by a variety of parameters true to its nature, such as density, food sources, sensory distance, rotation angle, and others. Through these experiments, we acquire the foundation to later catalyze these parameters to different environmental and geological factors, such as topographic elevation, wind forces, water bodies, hazard maps, vegetation maps, and others. At the nodes of our ecosystem would be another generative master plan on a smaller community level that adapts to various terrains. Each of these communities represents a self-sustaining and resilient colony, which are epicenters of bioremediation. Moving forward with our prototype environment, we focus on Volumi National Park in Australia, which is an example of an area heavily razed by bushfires. We have broken this zone into different data maps: burnt areas as our ecosystems, food as burnt soil. Food as burnt soil has been studied to be more fertile. Green areas as vessels to house the spores as they settle from the atmosphere. Altitude and slope as growth extends. And finally, wind currents to influence the system's behavior. Through each and every simulations, for each factor, we tested different behaviors. By doing this, we understood how each factor affected growth. In the end, we were able to design the algorithm to react to all of these factors altogether, forming a seamless adaptation to the geology. The result? A generative master plan that weaves through the terrain, capitalizes on hazard areas as food sources, reacting to wind, and is rooted from nature's system. Within the spaces are its own intelligent organism growth clusters, which find its way to optimize a balance between public, industrial, commercial, and private nodes. Through this design, we aim to find solutions at the source of each planetary issue. As people hurriedly take off, finding the next planet to drive into deterioration, we stay to make sure that the planet who once provided our oasis will also provide for our generations to come. Altogether, the design systems work in sync to achieve a singular macro goal: growth from decay. In 2099, would you even need another Earth? Thank you.
Thank you.
Wow.
That's great presentation. Great presentation. Thank you.
Great logo as well.
Really amazing presentation, and I really wanted to see that project, all the chapters, like a movie. It would be really amazing.
Thank you.
And once again, I really like to know how also you finished it, because it kind of wrapped everything together, that when people are looking for other planets to drive to decay, you would like to stay and actually just, well, find a way to capitalize on something that is killing, right? Something that is dangerous and is not, well, obviously good for living organisms to thrive in. So that is very good, and I really like that you used fungi here as an inspiration. Like some other teams also use that, and this is great, you know, to get inspiration from fungi on how to actually inhabit something that is seamlessly uninhabitable for any other life form. Yeah, great project, but in terms of that master plan that you provided us with, once again, if you could just zoom out a little bit. It's not too clear, you know, what is the structure of that society, because it looks like you have separate clusters there, but do they form, what kind of system do they form together? Is it more kind of a country-like system, or is it more of something that you would call an agglomeration around a hub, like a main city and agglomeration along that, or maybe it's something else? I mean, what is the spatial structure of that society exactly? Because it's not too clear from that map. You emphasize very well the net, right? Like the network of the connections there, but what are the actual places where people live and do stuff, like grow food or just live their lives and do other stuff?
Yes, because the scale is actually really large. These small areas are actually the amalgamations, or the chapter 3 that we designed. So if you look at it at this scale, it's probably close to a large city to
Yeah, so you basically focused on generating something of a larger scale there. Well, then you know it's not obvious where is the public spaces and where are the private spaces, and maybe, but once again, it's not clear to me because you did not emphasize where there is a distinguishment between the two, right? And between the other functions. Well, it makes sense, right? When you take a look at that from above, right?
At this scale, even with the cities that we have now, you wouldn't be able to tell, like looking at like from such a far distance. You wouldn't tell in an actual map that exists, that's real. You wouldn't tell the public and the private. I mean, they're working at such a big scale that those things are probably better explained when they talk about the amalgamation.
But I mean, you know,
the scale is wrong for the whole network, or not wrong, but just so immense. Like, what type of road or whatever this is so big that it's almost the width of a whole city, neighborhood, village, or whatever this is. Like, it's insanely huge. Then it has to have something in between, or it has to be explained why this is so big, no?
I totally agree. I think that it is out of proportion. Also, the map doesn't do justice everything. It's just yellow. The smaller clusters that are forming, which are the cities or neighborhoods, like they're so small, like you can really realize them until you really zoom in. And we want to be able to have this hierarchy very clearly visible, as much as also the public spaces. We keep talking about these public spaces, and I do not know, that's a general comment to everyone. I don't know why you guys like in a way like forget them or disregard them, or you know, like they're major, you know, like in every cityscape. Like, it's what actually drives a lot of the decision making of like how actually the city is forming. I'm not talking only about this project, right? Like, it's a general comment to everyone. But I totally agree with that. This, you know, like you have a very dominant network that it's taking over in such a big way that it's just not allowing us to see the clusters which are in a smaller scale. And if you actually wanted to do that, you could have chosen a different visual language, but then zoom into one of the clusters, right? There is always a way to do what you want to achieve if you wanted to work on a greater network. But still, I think that there is, you know, like you do need to reconsider like some of your practices and how exactly like you are showing this work.
Yeah, but once again, let's repeat that. But on that scale, you know, on that scale that you did the project, it was very good because it was very data driven. It was very consistent with the philosophy of your project. That part you nailed it. You nailed it really well. So I guess what we were talking about is the next step would be, you know, to come a little bit closer and to distinguish the different functions that you have there. So it's more, so it resembles an actual environment that people could inhabit, right?
But we have public spaces, by the way, these bigger nodes.
Yeah, they are, but they're just, again, the scale of
spheres,
network and secondary network with amalgamation and public scale, these two don't fit together. Either the one is out of the proportion or the other one is out of proportion, or they lack something third in between that we don't have here. This is what we've been talking about, like basically since you shown us this, that it's so big, or these are so small that it just doesn't make sense. How are these connected to these bigger roads? Why do you need these immense, imagine these are immense roads. What is happening there? Why do you need to have 3 amalgamations type of a road? It's like, and the amalgamations are already amalgamations or clusters of the actual corpuscles. So it's like, we're talking here out of proportionally insanely huge. Or, as I said, there is something missing here that will connect the one and the other. And so, yeah, I think you're one of the teams that have insanely good presentational skills. You can both speak and talk and explain and make money shots and flashy images, and oh, it's insanely beautiful and great. But sometimes you forget, these little details that are actually making your project, right? So, because for new guests or tutors, when they come, they're so impressed with the way you present that they forget to look at details, but we're already used to it. So we already know, like, it's movie time, as Nadia wrote, like, take the popcorn, enjoy it, it's amazing, it's always is. It's like, I think once I heard a joke about ABBA, that they're always, always the same and always sells, because it's like, you always know what to expect, it will be great. But then just, these are things that if you want to improve your project, we have to pay attention to them and work on them in the last semester, basically. And it's not a bad thing. I'm just saying that, we know.
Yeah, but your data-driven solutions are great. So I guess, this is something that you can definitely incorporate just if you come closer in that project and actually, work on that smaller cluster there, where you can emphasize, how that new environment that you provide the people with works. Because once again, you took the data and you turned it into design. Great. I mean, not like that, not straightforwardly, but you actually processed it in a meaningful way. So that, hooray for that, really. It's, yeah, there's just a couple of things.
Thank you.
I would also add, like, at least from my perspective, I think that we can look at the roads and the networks as diagrams, more as of, like, this is not a 3D model, it's a diagram, it's data. And I think the thicker they are, they can represent more, like, or denser areas, they can represent data, not so much like the real thing, for me at least. And I think they balanced quite well, at least at this scale of the map, like something that, has the empty spaces, has the, the different clusters, all the information is quite structured, and it doesn't bring in any elements that are overcrowding it or overwhelming it. But yes, I agree that they should probably have like a zoomed in part in which they definitely could explain better what happens with the, all the functions, all the public spaces and the private spaces. But I see their project as data, and I mean, to be honest, it's one of my favorite projects, just because, like, they just managed so well to, like, not overcrowd the map, see a clear connection with the map and the data. And from my point of view, I see it as data, and I think that they really managed to create areas of density, and without, like, having too many elements combined, with just a few elements, they managed to create, like, a lot of differentiation on the map. And I think that's really powerful from their, like, getting a new tool and, like, learning to use it so well, and, like, combining it with the storyline in such a way. I think it's like, they should be congratulated for that. And yes, I think for next steps of improvement, would definitely help if we would have, like, a zoomed in part where those dots become more realistic, and the roads are not so thick anymore, and we get a more concrete way of seeing things.
If it's data, I have to add, no matter the zoom in or not, that it needs to be explained and fit into the bigger concept of what they're doing, because that's just very abstract just to say, yeah, but I'm representing data, although we know that this chapter is that, and it has this, all those very complex structures with the plugin.
We were talking about the cosmogony scale, and now we want, like,
but still, it's,
I don't know,
yeah.
I mean, for me, it's a little bit blurry in terms of, like, we're talking about the cosmogony scale, and then we're going into the city level. They created many clusters of cities. That's their scale that they worked at. And I think it's very good.
Right.
Okay, thank you.
Everyone agrees, data is there, the logic is there, the project makes a lot of sense. Representation-wise, you should improve. Right, like I think that everyone agrees on that. For clear direction on next steps. We want to see this improved. Okay.
All right.
Thank you guys.
Right.
Thank you so
Other
much.
than that, you know you're killing it.
Yeah, good luck. It's our job to tell you something, to find something that's wrong, right? Just so you can improve it. But it's
exactly. We're searching.
That's a curse, yeah.
Yeah, but that's the thing. We're all constantly learning, so.
So don't feel disgraced. Feel the encouragement. Feel maybe go a bit angry about it and turn it into energy to produce some better design with it. Yeah, that's always a possibility.
All right. Thank you.
All right.
Thank you. Team A1, Annette and Atish.
Hi.
Hello.
Hello.
Yes. Hello everyone, we are Annette Kulcher and Atish Moon. Welcome to our Elevating Experience project. On every scale, bigger or smaller, the entire universe is conscious and connected, and we humans are nothing more than physical manifestations of it. Each living organism broadcasts energies, including the universe, and all energies interact with each other. Being conscious of our own state as well as the state of others is important if we want to create a better functioning society or a better world. Our main concept is based on the vibrational scale of consciousness as defined by the American psychiatrist David Hawkins. The idea is that when we manage to rise above the neutrality level of consciousness, we are in a so-called expanding state. Hence, we are able to levitate. The higher the energetic frequency, the higher the elevation we are experiencing in our simulation. The aim is unconditional love, as it's the most powerful vibrational energy that can be emitted by humans. For this reason, our experience suit on the prosthesis level represents an on-body feedback device, capable of sensing and collecting the consciousness of others, visualize our energetic frequency level, and output our current emotional state. The consciousness level of the prosthesis is sensed by the corpuscle unit. A frequency level of the body is made visible through the walls of our habitat, which can also levitate once it exceeds the neutrality threshold. The same logic also applies on the amalgamation and cosmogony level, where we aim for the visual representation of the overall consciousness of a bigger community. Here you can see our final experience suit design. During the second corpuscle chapter, we made our own fan palace, an Airbnb, air bubbles and blobs, called the Quantum Experience. We imagine our cyborg's private living unit as a dynamic multifunctional space. Our interactive walls are reflecting the consciousness level via patterns and colors. We have panoramic pods around the building to enjoy the scenic view from them, and our additional furniture can levitate as well to be able to move to a different space in case needed. The amalgamation chapter's design process started with the definition of our deployment logic. We experimented with different methods of Chladni pattern generation to form disks. The pattern of this disk represents the overall consciousness of the community, and these disks are further stacked into a cloud along the curve.
Speed it up on it, please. Yeah.
The public zones represented on two different levels are inspired by the Roman concepts of otium, leisure time, and negotium, business and daily affairs, where otium was a time to put aside political or career gains and focus on the progress of the soul. In the Kinesis chapter, we designed 3 vehicles: private vehicle with a capacity 1 to 2 people, flyboard, transport medium to cover shorter distances, and a roller coaster-like public vehicle with a fixed network and ability to carry 10 to 20 passengers. The public zones. Let's go here. Upper private network is indicating the movement of vehicles around the private spaces and public zones. The lower OTM network is a water surface independent public network around the leisure islands.
Annette, go to the next chapter.
Yeah, Atish will guide you through our current Cosmogony chapter.
Our deployment system is built in 10 stages around the frames of Chladni pattern sequence. As the corpuscle of our inhabitant with the same consciousness level are closely related, they merge around these attractor fields. Based on the frequency pattern, we define a catalog of different amalgamation options. Quantum clouds are the colonies of amalgamation, which is aggregation formed by corpuscle units with respect to Chladni pattern. This disk-like formation would grow along the curve in all possible directions, prioritizing verticality, considering the levitation ability of the prosthesis. This quantum cloud amalgamation are ever-changing, that is non-static at any given time frame. Cloud colonies are able to actively migrate across surfaces via a number of different mechanisms, including twitching, gliding, and levitated swarming motilities. These motilities can not only facilitate the surface translocation of individual cloud, but also manifest as highly organized multicellular swarm that enable rapid expansion of quantum cloud communities. Here you can find our inspiration for Cosmogony chapter. Around 77% of the galaxy observed by man are spiral galaxies. A mandala is a symbol of cosmos representing wholeness, totality, infinity, timelessness, and unity. Tree rings carry information and events from the timeline. Here you see our morphological studies of macrocosmos. The cosmos network inspired from neural system is made up of upper network, sensory network, which is responsible for collecting information and transmitting it to the motor network, which is lower and responsible for motility. Middle network relay connects all the amalgamation and work as a link between the two. OTM negotium spaces from amalgamation, public zones as vegetation. Tree ring hold information and events from the timeline. With our circular and ring pattern, we are trying to indicate the growth and changes in amalgamation at the master plan level and their networks. The sequence of patterns are reflecting the plan in different eras, almost reflecting the stigmergic behavior. These ring patterns employ stigmergic self-organization to coordinate their collective behavior with semitectonic and quantitative stigmergic system in the form of trails. Here's the map of microcosm showing the idea, and next to the zoomed out version, the macrocosm. The following images are transformation stages between the two maps.
Okay, thank you.
And here's the tiny GIF showing the
Is that showing the change in time?
Mm-hmm.
Yes.
And so yeah, but it is showing simultaneously the society at all those levels of consciousness, right? And how it changes in time.
Yeah, how it can change in time and zooming out at the same time.
Okay, can we comment? Because I'm not sure. Let me just start. Well, first of all, I read that book by Hawkins, and that topic is something that, you know, can be considered as pseudoscience and so on. But I think you did a great design choice here, because it's very complex and very abstract, and kind of delves into how to present something as abstract as consciousness in a spatial dimension, in the spatial kind of form. And I believe what you did there is also, you know, you've abandoned that classical perception of architecture and public and basically the urban spaces and the spaces of human environments. So it's really hard, you know, to concentrate on that from architectural point of view, I guess, because we need to think in a completely different way here. But yeah, maybe the only thing that I lack here is to see more kind of relationships that you have there in that physical spatial form, because that shows us the representation of consciousness, right? And maybe that just was the whole idea, right? How the conscious of the people emerge and work together there. But once again, and I really appreciate that. I mean, that is a great concept, and philosophically, it's just it's something completely different. So yeah, highlights the interest there. But once again, I'm having a hard time connecting that to reality in some way. So
yeah,
so I don't know. Maybe you could
it's
just
it's an interpretation as you want it, I guess, or because everyone has a different interpretation of it, and well, this is how we interpret it. But
yeah. I mean, it's
obviously different from person to person, and that's what I liked also about the mandala idea, because Carl Jung also said like he drew every day a different mandala, and that also showed his own consciousness level, or at that
in
so
different
he would
states,
draw a different mandala every day, because it's never the same. Each day is a different state of mind.
Yeah. I mean, the concept is amazingly interesting, and I love that you wanted to take that and put it into spatial dimension, so that there is a different spatial structure in society than the ones that we're used to, right? And the people can actually levitate, and that is always consistent to this to their true state of consciousness, like if you were inspired by the book. So yeah, great job. I don't want to comment this from architectural perspective, because it's absolutely different.
Not easy.
Yeah, but great, and thank you for sharing this. I mean, yeah, it's definitely been a pleasure, to help you on the journey a little bit, and just to see it, and to see the result. Yeah, I'm very impressed.
Yeah, thank you for your help.
Just not sure how to talk about that. That's why it's more of a question than a comment in the end. Yeah.
Thank you, guys. Very cohesive project from day one until now. I love how confident you are in it, and how you're going forward, you're moving forward, and everything is very original. For me, I would be curious actually to see these connections in an even more three-dimensional way, even if they would be in a sphere, but then like rotating and then forming like with each other because of this like levitating aspect, right? Like it would be something amazing to see.
Definitely.
I have a little bit of the same comment with the previous group on the scale of again, like the two layers you have, especially on the left-hand side. So that's something that you can think of, because it just overwhelmingly, like the purple bigger network that you're having is like overwhelmingly like taking over. Maybe if you had another layer to zoom in more into
Can you zoom in, please?
Yeah.
Into those one image on. No, the central.
Yes, this one.
Even
well,
more.
there are multiple ones, so there are definitely layers in there. So we wanted to show like the motor one and the sensory one, and then the relay one, which is in between the two. It was not that easy to do.
Yeah, and I think the GIFs are your best friends in this project, right? Like in order to show this differentiation and just to explore the project in different ways. But really well done. I think that you're just like thinking about how to take it next, like to visualize it even better, right? Like and get even more excited about it. Thank you, guys.
Thanks. Thank you.
Let's stop moving.
Oh, stop moving.
Stop moving. Zoom in. I want to see it.
Even though like during the time we worked together, I would not get why you would do a mandala. I'm convinced now. And I think that like it's a very artistic perspective, and I really like it. I would say that like, yeah, it's very unique, this project, in terms of like mapping consciousness, and yeah, it's a very cool idea. And also like the graphics are amazing. Like you really have like really good presentation skills. Yeah, I really like the project, so congratulations on it. Like, you know, you seemed like you really knew what you wanted to do, and a bit stubborn at times, but I understand now why, because you know.
Always very stubborn.
Yeah, but that's great. That's great. That showed us, you know, your inner motivation, and yeah, and you definitely had it on some subconscious level, right? Because it's so strong.
I'm trying to listen, but if something says inside me, then in the evening, like, no, I want this. And then
no, you just don't listen.
No, I want to go with this.
Yeah, that's great. That's intuition, and you have it developed in a big way. Yeah.
Can you please just zoom in again in the left image? I'll just be super short. I want to explain something here. Yes. Okay, that's also fine. But so they have, like, I would like just to clarify the difference between this project and A2's project. They were at exactly the same level, but then the amalgamations were scaled up. The public spaces were scaled up, so we don't really see it so clearly. But if you look, you see that they're at least at some level much closer to the network level. And for me personally, and that just because, you know, we can all agree on what is something that's very ugly or something that's very beautiful, and these are general aesthetics. But I think then in the small differences between what is really very beautiful for someone, there are some very subjective perspectives, and for me this is the most aesthetical project of this chapter. I think it's amazing how it looks, and I think the depth that you managed to do, making it somehow three-dimensional, it's incredible. So that's my personal opinion. So it's really adding this greenish just made it much better, and of course scaling it up so that it makes sense. For me personally, in the city level, although it's not a city level, this is also immensely huge scale. But then these are small settlements. They have small forests or whatever they are next to it. You know, everything's floating, everything is there, everything is connected somehow. That's my, you know, my personal perspective on it.
But how do you see the difference between like the primary network, the purple one, and the habitats is different from the previous project?
Because of the scale. I'm not saying this is perfectly done. Of course, as you said, this first network is very thick. We can see it's insanely huge as well. But at least here we can see that these settlements, they're together in the amalgamations, they're much bigger, and the public spaces are much bigger. Here we can, like, Annette, please zoom in a little bit in one public
space.
Yes, where are the Annette, I cannot explain everybody's projects for you. Okay, this green blob in the middle of small dots is one bigger public scale, public space. So altogether, it's like it has this size of a network, like this size, and not this size of a network, this size. That's the difference.
Yeah, first it was also
for some reason in this master's degree we hate public spaces.
No, we have a little bit of a problem to integrate them, but we're learning.
But we're still like struggling with the public spaces. Okay, let's all in semester 3 focus on our public spaces. Okay,
can start with the public spaces.
That's why your project is so hard to comment on, because you did this checkmate trick there that, okay, this is consciousness, right?
Yeah, this is not a network of like.
No, but it can still be consciousness and a city in the same time. We can be that open-minded, so we can imagine it. So it's fine.
Yeah, but it's crazy. I mean, it's so hard to orient.
It's a fusion. It's a fusion.
Yeah, maybe, you know, maybe that is the next step. That is something that you can try considering. If this is levitation and it is happening in physical space, and this is fueled by the consciousness in some manner, let's put it that way, just for the lack of a better word. This is, you know, this is the better, the next step, you know, how to actually go three-dimensional, like Pavlina said, you know, how to create those spaces.
Definitely. Yeah.
What?
We wanted to go three-dimensional.
Yeah, you just, no one allowed you yet. Yeah, but as a next step, I think, you know, it only makes sense to go three-dimensional and to emphasize what is the difference between the spaces, what is the hierarchy there, because there obviously is, right? And you're starting with the hierarchy of the consciousness level based on those vibrations, right? So as Madeline says, you have all the ingredients. No, yeah.
Okay, thank you everyone. Let's
you.
take a 5 minutes break and then continue with team B.
specific moment. Vehicles. The modular approach is continued in our vehicle design with 4 typologies of AFAs aggregating with spherical wheels for private vehicles and multiple units of private vehicle which aggregate to form the public vehicle. The humans deploy their first ever city base in Libya, considering its need for quick revampment infrastructure and abundance of resources to produce the AFAs. The deployment of the starter clusters is along the water body. These clusters these clusters produce AFAs and expand by forming subsequent clusters around them. The AFA movement from starter to new cluster became primary connection between one cluster to other, which as they keep mutating form cities and districts. The animation represents the growth of our entities that are transformative and adaptive to changes over time and needs of the inhabitants, thus making it a city of change, solving the constraint of adaptation witnessed in normative planning.
So now let's look at the growth timeline. Initially, these clusters are deployed along the water bodies, and these clusters expand to form secondary clusters around them. The deployment of these development of interconnections between these clusters happen in the stage, and new connections emerge based on the frequency and the high traffic connections forming the primary networks. Secondary and tertiary networks emerge from the primary networks. Further, intercity and intracity connections are formed on the existing connections are optimized. Our master plan is a system of multiple cities with minimal associations or association-free connections between clusters, ensuring the entire region is to be adaptable. The development of networks between districts, cities, and neighborhoods and their interrelationship can be identified from yellow to violet gradations in a network system shown above. The places with high topographical difference are reserved for the development of public spaces with minimum intervention to the topology, thus ensuring a city that is adaptable to change, sensitive to natural resources, and truly respects its topography. The regional network is thoroughly well-established connections between various cities to organize social, economical, environmental, and spatial distributions of resources. Areas of close connections from the centers to the informed decisions of each cluster formation and uniform distribution of resources help our city to develop with multiple centers. The city network with thicker connections represent areas of key movement and the secondary movements in a fainter connections. City plan. The formed group of clusters establish a connection between each other, creating networks with opportunities for new developments along the connectivity corridors, and to accommodate utility sharing services between neighborhoods, further reinforcing the concept of sustainable development. Our map constantly evolves and establish networks that are sustainable, adaptable, and transformative, similar to the behavior observed in slime molds, which exhibits a collective intelligence to create optimized networks, thus staying true to our transformative logic and self-assembly system logic of our project. Thank you.
Thank you, guys. Exactly 5 minutes. Thank you. Great presentation.
Why are we not seeing Pradeep?
I'm here.
Yeah,
okay. We can get only one from this team. Good job, guys. I think that makes a lot of sense, like everything and how you're thinking about it. There is a lot of intricacy and detail when you're zooming into the networks and the logic that you're deploying. I would think of a secondary also like network that could work with it, right? Like, or maybe like a little bit like, can we see like this city plan maybe that could be a little like bring a little bit more of intricacy on a different level from the work. But yes, I can see now like the more like of these neighborhoods forming around the cityscapes. And since your networks, the only thing that we need to keep in mind is since your networks in mobility, they were very, like with the straight lines, right? Like you need to consider them when you are actually representing them in this scale too. And I think that you have tried like to do that more or less. just to keep cohesive, and again, this is not just a comment to you, but to everyone, right? Like if you're showing a network of mobility that it's straight and then like it's curved in this level, it doesn't really like correlate. But here, like I think that you've tried to do some of this work.
Yeah, I guess we still need to add more details.
Yes. Yeah, definitely still need more work on the city level, but yeah, that's just an addition of the cosmology level.
Yeah, just to follow up on that, if you create such a network that is so diverse and has that many turns and well, as a consequence, clusterizes the terrain in such a manner, it only makes sense that something is happening in those clusters, because otherwise, you know, why clustering? It would be easier just to connect the dots, right?
Yeah.
Or at least follow the terrain to connect the dots. But there's obvious clustering there that is happening, and most of the clusters are empty. So that just, you know, that begs the question, why?
Yeah, that's
all in all, it's great. It's really yeah. Sorry for interruption.
No. It's just that it was very hard for us to visualize everything in 2D. Like for our project being so transformative, we wanted to see something in 3D, so we can say, okay, the space is created between the cluster, the network systems also can be utilized. But sure. Yeah, we'll work on it when we start developing this in 3D in next chapters.
Yeah. I mean, you have everything. Once again, yeah. Sorry, Madeline, you have all the ingredients to make a great 3D thing. I mean, to have a great next step. Yeah. I just love, you know, how Madeline puts it with this ingredients thing. It's very, very good way to put it. Yeah, and great job. I mean, all in all, and technically, really, really great.
Thank you.
Thank you. It's just, you know, it's the conceptual part that is bugging me a little bit with that. But yeah, once again, I'm pretty sure you will be able to do that in the next step to bring more meaning to that.
Yeah. Any other comments?
Yeah, maybe I can add something. Yes. I think I somehow agree with Kirill on the, I think that
sorry, we don't hear you too well. Something with your microphone.
Okay, yeah, I think I need to switch to a different microphone in a second. It's this one, yeah.
Yeah.
So I think there is I'm sorry to put it that way, like, but in the context of all the projects, this one, I mean, maybe we shouldn't really compare it that way, but I mean, looking at I don't want to compare you like one-to-one, right? But I want to compare the usage of tools rather, right? So not really saying what is better or worse, but rather given the available tools, what I'm missing here, right? What I know that was possible with other projects. And I think it was really the city plan level here, as I think you already said, but also the overall density of the design. It seems just a bit too simple. Maybe the underlying layer, the topography layer, is a bit too sparse or not really detailed enough. Yeah, I think that's it for me. Okay.
So what you mean is that it's a bit empty in terms of the information that was provided, or in terms of the project that?
I mean, just pattern-wise, like these patterns are very sparse in the end, right? I know that you can zoom in, but I think that it's just it looks like it's like a simplified map, right? It looks like it's already like being simplified and synthesized, like you have a normal map and Google Maps satellite view. This one looks just like a normal map rather than a satellite view, let's say. Where I thought that I mean, with those tools, I think it was a bit more possible to go more into like just generating more content, more layering, let's say, right? So yeah, and that's actually true. Like for each one of those, there's at least what I can see at the first sight is like there is always two or maybe 3 plans in each one of them, right? Like 3 layers in Photoshop, really, like one pattern, other pattern, background, right? And that's really, yeah. And that's really something which I think it's,
yeah. Actually,
it appears a bit simplified, yeah.
Yeah, actually, the reason being what we wanted. So, like when we were trying to use different layers, the connection between them just by overlaying was not good enough for us. So, what we tried is to use one single like the script to generate all the levels of connections. But it was not enough, so we tried to zoom in and try to develop separate logic for the zoomed in portion. So we developed 3 different maps just in case, so that we show differential like different logics being applied on different scales.
Okay, if you say you want to use the same thing to different scale, I like this idea a lot, but it would somehow imply that you go into fractals. And I can't right away say if I can see the fractals here. But yeah, maybe that's what maybe not design, but really the presentation is lacking, right? Because to see that, like, imagine that you can actually zoom into this map and the more detail is just revealed in front of you. It's not right away apparent that it's actually like that. But I believe that's what you mean. Okay, so maybe
that was the target, though. Actually, like we were discussing this with Madeline also from the initial stage. But that was the target, to actually have a very detailed map that you zoom in and you see more details, and you zoom in, you see more details. But the logic with the nuclei was not giving such results, or I don't know, it's the limitation that we have. But so that's why we started developing different maps for different zoom in levels.
Yeah, and they also like work on the desert, so like the map sites, the current stage that it states that they don't have that initial line.
Yeah, but okay, so I get the technical limitations regarding the desert. I think that it could be presented in a way that it would just not be suspended in a void right now. I think just that the ISO lines pattern is just not giving much information, really. Like, imagine that you just have a depth map of the desert rather than ISO curves, and like have a black and white, background. It's somehow there. I think I see there are some wider, like brighter regions, right?
Yeah.
But yeah, maybe it's.
No, actually, we used a heightened fill map, but to represent it properly along with the network system, we kind of created the surface for it and sliced and put it beneath the network system, just for the graphical representation purposes.
Yeah. Okay, I mean, that's it. I don't want to. Yeah.
Thank you, everyone.
Thank you.
Thank you, and keep it up.
To the next
Keep it up.
A9, B9, Naresh.
Hey, hello, everyone.
Hello. Can you stop sharing?
Yeah. Okay. Can I start?
Yes.
Okay. So hello, everyone. This is Naresh, and welcome to the project Cybernetic Autotroph Evolution. We live in a period of constant change, uncertainty, and crisis, where the planetary boundaries are being exceeded out of their limits, creating a natural imbalance in the nature. Climate change, deforestation, and food chain destruction have created a massive destruction to the mother nature. In order to investigate this and try to solve this, we are interested to use the knowledge of the autotroph in order to co-create and co-develop with them in order to reach a balance and equilibrium on the Earth, with a total vision to redesign and rewild the site to reach a state of equilibrium. In order to envision this, we started with the wearable interface, which will act as a medium to sense and communicate with the various family of the autotroph. It will also act as a symbiotic connection to learn, grow, as well as emerge along with the autotrophic families. For the cybernetic humans, to accommodate this cybernetic humans, we imagine a kind of like an autotrophic arc, which is like an integrated housing in the research center in order to reconnect with the nature. This is the place that will allow the cybernetic humans to establish a two-way communication with the family of the autotroph and other non-human agencies. And to envision this as a collective intelligent society in terms of like amalgamation, there are like different amalgamation clusters that are connected together to form a very intellectual society with a balanced flow of food, resources, and energy between various sites. To form a kind of like a symbiotic network that will connect various intelligent societies to connect together, a transit network is inspired and powered by the algae that will allow the cybernetic humans between various clusters to move around in the aid of the public as well as the private vehicles. In the cosmogony level, in terms of like a studies, I tried to choose the Singapore country as an entire site in order to study the total transit network system. So it followed up with various transit network studies, gaining the information about the water locations of the city, some kind of particle simulation, and some map voxel simulation and clusterings done in DLA. And finally, I tried to do some kind of like computations with multiple layers and combining the different layers of particle simulations together in terms of the studies. With this, in order to describe the master plan of the entire site, the first approach that I took is the hydrotropism. Hydrotropism is the growth of the organism towards the water resource. For that, I wanted to take the help of the marine algae that is available in the water all around the site, so that I can use the water network mapping of the site and then able to call them such that the marine algae will come into the society, and then they can provide energy, nutrients, and recycling of the air via the help of the water network around the city. This as the first layer. I tried to go with the second layer in order to achieve an urban rewilding, where I tried to map the vegetation location of the city such that all the national parks of the entire site is being located. And I use this as a point source, as a foot source for the particle to kind of like simulate and create the main transit network. So this main transit network is the locations of the tech as well as the energy centers that is spread all around the site and creating a main or the important transit network around the entire site. In the third level, in order to create more community cluster spaces and create more private network, I took the highway network of the Singapore site, and then I tried to do the particle simulation to create more cluster spaces for the community, as well as for the private network for the people to move around the entire site. As a next step, I tried to investigate various neighborhood deployment based on two strategies of the amalgamation clusters. One is the garden integrated clusters that can be placed around the water network of the for the autotroph needs. So this is a good example that you see on the right-hand side. The second one is the dense housing clusters that can be deployed along the private network in order to meet the city housing needs. So wherever there is huge amount of population that is needed, there can be more dense housing clusters of amalgamation can be clustered together, which will be shown in the map. In terms of like city features and public spaces, I try to explore in terms of like community garden, autotroph night market, autotroph museum, and permaculture research space, and autotroph food center. One good example is shown here. It's a community park that is being in the center of different amalgamation cluster units. As an entire site. Okay. Yeah, so this is the entire site of the transit networks that is being shown. To zoom in, the dark green, that is a glowing green, is the main transit network that will be connecting the entire site with the help of the technology centers, where you can see the private network and the waterway network is all symbiotically or synergetically connected together. For the next zoom in, so this is the water network, that is the marine algae as an agent that is coming inside the site via the water network of the site plan. This is an image of the clustering of one of the dense housing blocks that is clustered around the private network. This is an example of a community park that is connecting different types of amalgamation clusters and then providing them as a common space for different peoples to communicate and collaborate together. So this is a space that is created around the water body, which is a permaculture fit space. Okay, permaculture fit space. And so this is another example of the amalgamation site. This is how one of the clusters that looks like. And yeah, this is the entire city, where the aim is to rewild the city and then slowly achieve the point of equilibrium. Thank you.
Thank you. Thank you for the presentation. Any comments?
Thank you, Naresh. I think the way you presented it, it's quite clear how things connect, and I think that all in all the logics are there, the things connect to each other. It's just that at the end I feel that you have the ingredients, but you need the spice, like something to, I don't know, make it pop a little bit, or make it more, I don't know, aesthetically somehow that we can, I don't know, something that will bring a little bit of joy, because it's like, the logic is there, things are interesting.
Isn't that the color palette? Because I have exactly the same thoughts on that, Madeline.
I mean, could be the color palette, or I don't know. I just feel like in this, it's like it's not overcrowded, like it's simple, but it just feels like there could have been some spice, something that would pop up and make it like
I think it's
give us a little bit of excitement,
Yeah, I think it's representation again, though, because again, you have this primary network that it's so heavy, right? That it's taking over, and then you can really appreciate so easily the beauty of the secondary spaces. But I actually love this project because it's thinking a lot about the existing space, right? And how the clusters are deployed, the different spaces. So it's not just a, tattoo that you can put on your arm or a t-shirt or looking good, but actually Naresh is like following a very clear logic and is thinking about the city that actually is occupying here. So that's definitely a great thing. I just think that this primary network with the circles is just looking more like a map to show you like where to go around the zoo, right? So I think representation, right? Like the logic is there, the work is there. It's just more about like going back and seeing what's the best representation for this work.
The architecture is there. That is very important. You can really see the hierarchy there. You can see the structure, and that is great. I mean, the only thing that I thought might not be well, that bugged my mind a little bit. It was that you have those kind of suburban areas there that look very classically. That they're just branching out from the communications. But once again, who says that it's a bad thing? Maybe it's a good thing. Maybe there is the way to still be very close to nature if you don't want to live in those bigger hubs. And because a lot of people even nowadays they decide to switch to that kind of living environment. So yeah.
Okay.
Yeah, I mean, it's really good to see architecture here, and that you have been using that it is data driven, and you did not go too far with it. That is great. But the spike, I guess, that Madeline was talking about is that that it looks kind of down to earth. And I'm not saying that it's a bad thing. It's just maybe in the next step you can introduce something that we did not see before as humans, right? Something else. I mean, only if it makes sense, of course. This should not be your goal. Your goal should be to create good design, right? To solve some problems there, and you definitely did it here.
Okay.
And yeah, hooray for the hierarchy. This is a very complex thing to do. Okay. And maybe that's one more thing that you would like to improve later on. Just, I mean, if I was to give you an advice, try to criticize your project, try to find the weak spots there, and that should give you some insight on how to make, for example, those hubs maybe more specific. Because right now they're generic, right? You just have hubs there. I mean, in the intersections that create the main network, right? Maybe there's a way to make them more specific, more kind of authentic in terms of what do they provide to that society there.
Yeah, thanks, but you should move a little bit faster.
Okay.
Okay, next one, please.
Thank you so much.
Thank you. Great job.
Walter. Hello. You have exactly 5 minutes. Nope, not the screen.
Yep, here we go. Okay, exactly 5 minutes. Okay, so welcome to the Age of Autotroph. And in this chapter, I'm going to introduce you to a new continent called Atlantis. The vision of autotroph technology is that through cymatics, the study of cymatics, the communication with autotrophs has been reestablished, and they are able to start dressing our character Auto1 here with all kind of different autotrophs that help him be his best self. Then we move on to kind of building the ARC, which is the mobile exploration laboratory for Auto. At first, they start going for explorations to the most exotic places on Earth, but they also start tackling some of the new opportunities that are arising on Earth. As that knowledge grows, a university called Osiris Acacia Botanical Academy is established in Cairo, where they build arcs, they create different academies, and here you can see a little bit of how they're building it down near their agora. We moved on to having what I call divine, which is basically the first of the abilities to have a circulation network. And then we have the sundews, which are instead of the way we travel on roads now, because we want to allow all of the boundary layer to be populated with autotrophs, this can actually fly. So where are we going to put, we don't put it anywhere. There is a giant field of trash building up at Point Nemo in the South Pacific, and the autotroph world has decided that this is where they should focus their energy. It's kind of between Africa and Australia and the Arctic Circle, about the size of a third of Australia. We start studying the different types of networks that we might need to get to the new continent, to get around the continent, to get around the freshwater areas of the continent, and then to get back to the divine network. So lots of different studies. Okay, so now we get to Atlantis, and we start seeing the ability to navigate the arcs to ports, to get to ports, to start building the academies. From the academies, we start having this aerial network for the sundews to get around. In conjunction with the academies, we start having larger agoras and larger parks, and then we start having the ability to circulate via the divine curves. So when we zoom in on that, we can get a little bit better sense of the detail of how all 4 of these networks would work together to serve ports, academies, and then what's really hard to see is in this little area over here is where you start to see those early arcs starting to aggregate as the academies become fuller and they start moving out onto the land.
30 seconds more water.
I'm done. Boom. Thank you.
Okay, I just said you had 30 more seconds. Not that you hadn't done. Okay, thank you. Can you zoom out to the main map? Let's have a better look at it.
Sure.
Excuse me, just since you finished the presentation, could you please add like 1 or 2 sentences to sum it up? What do you think about it?
What do I think about it?
Yeah, you called it an opportunity, and I really loved it. I mean, during the beginning.
I think that the ability to take one of the foremost of problems from a society that really can't help itself making trash, and we have more people than ever, and we keep imagining that we're going to modify behavior by telling people not to do things. And I think that's going to work, and I think there's a whole crew that's working on that. I think as a problem solver, there's a problem that's going to keep existing for a long time. And I think that this idea that trash grows in the South Pacific and becomes a viable home for autotrophs as well as other heterotrophs is going to be great. I think the ability to get there and start having locations, 2 sentences. Yeah, I think this is it's a once in a lifetime opportunity to kind of evaluate the continent and try to learn from everything we know as humans and be continued to be taught by the autotrophs with their 4 million years of knowledge. And I think it's going to be great.
Okay, yeah, I really like your project, and I mean, from architectural point of view, this is very original and very interesting, to think about something that is a problem you thought of it as of an opportunity, and yeah, that is just great. The only thing, because provided it with architecture, you have the philosophy of the whole thing, and that is great. I just was wondering, what about the water? Because you've also emphasized that there is fresh water there, and how did it get there, and how come it's fresh if it's an island of trash?
Because it's not an island, it's a continent. So as these barriers start to establish themselves, they go down to the ocean floor, and similar to all coastal areas, you start to get like the first level of less salinity, kind of the bays, and those are all around the outer edge. And as you continue to move in, you move into freshwater areas.
Okay, so your assumption is that there will actually be access to the freshwater, because basically you can speculate about that, and you can also make a case for a technological solution of using the water that just that is there, and
there's
something like that.
There's a whole freshwater network inside there. That's the kind of lighter pink color that's inside of the freshwater.
Oh, okay. Well, then something that I would love to see maybe more of is more of an infrastructure there, more of some real settlements, because right now maybe it's just a wrong stage, to make that comment on, but this to see maybe more growth on the continent for the societies.
Okay, thank you.
But yeah, great idea. I mean, in terms of philosophy, it's and the idea of the project, is really something.
Well done, Walter. I think that you're really enjoying the project, and it shows. You're really thinking about each stage and what it means for you, and each stage is actually different from each other, like as a language, but it somehow like works all together. Now that like you can go back and see everything from chapter 1 to 5, And I like, again, how much thought you've put into the process in each area that you're developing. And again, the zoom in and the bigger map and how you're connecting them, right? Like you're really, the presentation is well thought of in a way, like to really display the complexity of the project and also to convey the message. So well done from me.
Yeah, we still have a few things to clean up next semester. So yeah, good job all for coming to this stage. Let's move on. Sorry for that because
Fang and Madeline, thank you for all your help. Without you, this would have been a disaster. So thank you so much.
Walter, thank you for taking part in this and for all your feedback and your curiosity. And I really enjoyed working with you. And yeah, I think your storyline is one of the best, one of the most original, and it's a well thought project. So yeah, I think you can if you continue working on it, I think you can have a really strong project, especially since all the philosophy is there and it's intriguing, it's capturing everyone's attention. I mean, from the first moment you started talking, you captured everyone's attention. So you really have a gift with this, and now you have the ingredients. It's a question of taking a few more steps to get more work. But yeah, I really enjoyed working with you, and good luck.
Thank you, Melanie, for the comments. Let's move on to Tim.
I have a little suggestion. It would be really great if you wrote it down, later on, kind of create a publication out of this because it's a huge story. Yeah. Oh, sorry. Just a little thing.
Yeah, you can say.
You can also write in the chat, Kirill, when ideas come from previous work or anything. You can also write to them in the chat.
Kirill, I hope it's okay to still ask you for some scripting help.
Yeah, sure. Yeah, just write to me and I'll help you. I'll be happy to do that. Yeah.
Thank you.
B8, Dean and Paco.
Hello.
Hello.
Okay. Hello, my name is Dean Collins, and this is my partner, Francisco Nassar. Together, over the course of this master's program, we've been developing our project Restorative Homeostasis. This project began with the identification of stress as a growing epidemic that can be identified on the individual, community, and global scales. For our first chapter, we aim to address stress on the scale of the individual, designing a wearable that relieves stress through the application of pressure to tense areas, ventilation, compression, and support. Moving into the corpuscle chapter, we sought to address stress to the organic layout of our designed living space for efficiency in inflatable and deflatable furniture to imbue adaptivity to all the spaces. In the amalgamation chapter, we used our structure as a bridge between two parks on the lakefront of Chicago. This structure consisted of a base and 4 different organizations of new corpuscle pieces to suit different parameters: housing, commercial and retail spaces, a yacht club, and a spa. Located on exposed base areas, we situated public spaces for visitors and residents. Our kinesis chapter focused on the development of a public rail system that connected 3 key points in each park with 3 key points on the amalgamation. This aimed to provide efficient transportation to critical areas of the amalgamation where the previously identified programs overlapped. The private transportation system was also designed with efficiency in mind, connecting different corpuscular units to one another through a system of multi-layered roads.
Before iterating on nuclei, we took inspiration from old maps, man-made landscapes, and natural landscapes such as river networks. We also looked at density and diversity maps. Since we are located in Chicago, But at the end, we decided to work with this map that shows the cumulative burden of environmental exposures and population vulnerability, indicated by environmental factors such as air toxics and traffic proximity, and population characteristics such as low income, linguistic isolation, children under age 5, and adults over age 64.
To begin our design process, we experimented with different formulas for nuclei to find the direction that best fit our design goals and followed our inspiration. To aid our control over the slime mold simulations, we developed a series of maps focusing on different aspects of the city layout we wanted to exploit: waterways and water bodies, parks and roads. In combination with one another, we used these maps to help define or break different aspects of the city grid.
This is the area we worked in Chicago with. Since Lake Michigan's water levels are rising, we wanted to imagine the layout of these waterways, creating new transit systems that aim to reduce stress.
For the waterways specifically, the parks and road maps were used to create this expansion of the waterways into new territory while following familiar paths through the city. The goal of this deployment was to provide new connections between the areas of the city identified as stressful and to bring back nature into the cityscape. Both of these with the goal of reducing stress either through the greater presence of nature in the city or the use of the waterways for transportation directly to surrounding parks.
These are the primary roads we selected, and then for the secondary roads, we altered the grid where the stressful spots were located. And then moving to the tertiary network that creates Somalis in the blocks.
In the development of these road networks, we sought to introduce a more organic system that provided a more efficient network for transportation. Throughout the development of this system, we also sought to develop the parks themselves with the goal of creating a more organic entanglement between the city and natural areas.
Here we can take a look to where our amalgamation is located in relation to the map. Thank you.
Can you go to the main map and zoom in and stay there?
Thank you, guys. There is a lot of thought and work that went into it. It's clear. I wish that the maps were a little bit clearer to see or sharper. Maybe like with Photoshop again, you did the same trick there, like that you're like smooshing them and doesn't really make them, you know, like clear or beautiful. It's actually very difficult to understand them, and you're losing the information that you've built up through them. So definitely reconsider the way that you're representing the map. I think, and also while you're explaining the project, I think that there is a lot of opportunity to explain each step individually, right? And focus a little bit more on this, because it's evident to you that you build the project, but not so much to us. So we want to hear this story more than, you know, like anything else. So yeah, but thank you, really great progress.
Thank you.
You chose a very interesting and important problem there in terms of stress, and the solution of healing the stress with the help of providing, you know, more access to the nature, and the water flow is very symbolic there. So yeah, great work with the hierarchy and with the connectivity of the areas to those new green areas that you provide there, and that will emerge with the Lake Michigan going out, you know, into the streets, kind of. I don't know what else to add here. It's great, really nice job, and very nice solution to the problem. I mean, it just seems so elegant, you know, to to provide the nature into the city to help people cope with their day-to-day stress. Just makes sense at all levels.
Thank you.
Yeah, there are parts of this map which I love. There are parts of this map which I would totally just wipe out. In terms of, I think it would add some clarity to it. So, you know, the stuff on the left is like really interesting. And then the stuff on the bottom left and then the stuff on the bottom right is also interesting. But then I think the middle of the map is just lacking some contrast, just generally. And in this case, I don't think it's a lack of, like, it's not the wrong palette. It's just a design which is, like there is something applied everywhere, right? I think that you could try to generate the same thing without, like the major bits are fine. The small bits are just adding some kind of, not really like confusion, right? Or uncertainty, right?
Okay.
And that's really it.
Yeah, I mean, you had a little bit more contrast when you were drawing the neighborhoods by hand. I mean, even when looking from afar, you could clearly see the density and so on. So maybe it's just a question of representation, working a little bit more on that. But other than that, like the project is really strong. Like you have a very nice concept and you're implementing it in a very nice way. So congratulations on this. We know the potential. Like if you could just make it like more contrasting, then it would be clear to see for everyone. But great project, guys. Congratulations.
Thank you. Thank you.
Amazing project, guys. Congratulations also from me. It's really nice. And great analysis on the vocation and everything. And I agree that you could you should make the final map a bit more clearer, so it is visible.
I think we developed all these things separate, and then when we brought them together, they sort of started to compete with each other more than they complement each other. So we'll rework that.
Yeah, like the map like 2 days ago was a lot clearer. I don't know like why you add like a lot more stuff into it, but yeah, it's easier now like to reverse back. So it's fine. Thanks guys. Okay,
what was this Photoshop filter called? Like that it's basically like creating this, I'm sure there was a Photoshop filter like that was making this.
I think it was when they just moving on and mirror doesn't load when you share screen that way, and it's kind of blurry.
So it's not intentionally made. Oh, okay, good. Now I can see it when I zoom in. Yeah. Oh, I can see, guys, now. I thought that you photoshopped it on top. Good. Okay. Well, thank you so much. Amazing project.
Thank you.
Thank you.
Thank you.
Aranza and Eva.
Hello.
Hello.
Hi, can you hear me? Yes?
Yes.
Okay.
Okay,
Good. Okay. Hi, everyone. Welcome to Immersive Nuclear Memories. My name is Aranza and my teammate is Eva. Together we have merged two realities. The first world is deployed underwater and it's powered by nuclear energy. The second world is located in the city of Tokyo and maps the data of memories of people. The merge of the worlds is creating a new reality. Let's start. Society will be divided between Torio and RAM. Torio is the machine body is powered by nuclear energy, specifically molten salt. RAM is a garment for the human body that interacts with data in the city. As you can imagine, new humans will require new living spaces. These are the core puzzles, which cover new necessities and provide shelter in two different locations. One is located in the city of Tokyo, and the other one will be in the coast of Tokyo. The way the core puzzles are arranged in a vertical way from the neighborhoods to form neighborhoods, amalgamation above the city of Tokyo will look like this. that is in the top, and amalgamation underwater will look like this part on the bottom. For kinesis, we have designed these vehicles and that will flow through the networks and connect to the users. Now these are some of the images that help us map our concept that we're going to explain now.
So in this chapter, we have memories that are no more independent to each processor's corpuscle or city, but sublimed with the environment on a larger urban scale, which we call as molten memories. The cosmogony shows us the perspective of our past and new memories in a sublime nature through its exaggerated scale. In this level, the boundaries of urban scale starts to melt, just like the individual and the shared memories blur to collective memories. The first layer of transit remains the individual memory, where we use the data of mapped subway as anchor points. This existing layer is laid in a discrete pattern which sublimes as we go to the next layers. The second layer is the shared memory layer, where individually discrete nature starts to dissolve into rectilinear organic transit systems. While the third layer becomes the last and the thinnest layer, which are collective memories of the entire system and no more independent to the discrete nature. They become completely organic in this layer of data, hence molten memories become the archive data of a collective memory.
The concept that we create underwater starts with the idea of memory location and transportation of those memories generating energy, generating neighborhoods that need networks to connect that will develop the city and the public spaces.
We start exploring with the subway anchor points to achieve the complexity and layering of our networks. These anchor points further develop into the public spots of the city.
In the water exploration, what we try to do is use attractor points that start creating different patterns that will help us create these spaces in that we needed, like public spaces and parks. So and what we have with these results is like public networks, coral public parks, and public spaces out of it.
The primary and the secondary layers are in the rectilinear organic fashion, leaving the discrete nature. We experiment on different mappings and the anchor points. While the tertiary layers is led to act more organic, which depicts the memories getting sublimed with each layer. Some catalogs that we developed in our studies to experiment these possibilities.
You need to zoom in, ladies. We really can't see anything. Everything is very zoomed out in general in the presentation.
For aggregation and neighborhood clusters, we use the field lines aggregation from WASP to generate the neighborhood procedurally along with the transit networks. So the step one is we take the nuclei exploration that we use as a transit layer, and then we start discretizing these layers of transit to use as field lines. Now we have discrete field lines along the transit layer we use to deploy a site procedurally with WASP. Also, we work on the population density by controlling the depth and density of these field lines. Here's an example of how we develop along the field lines, disaggregations. And then we also develop different catalogs depending on the different population density. Here are the few examples that we put up here that are like iterated procedurally.
The last synthesis.
Now we explain the process of the final map. We layer the existing city with contours and existing city urban data. We deploy the site with our units in a symbiotic relation with the existing features. We generate the transit layer connecting these clusters. Subway anchor points develop into the public city feature. An overview of the whole network as follows.
Now let's explore the map of the city super quick. Here we can see the city above and underwater. We can locate the amalgamations of neighborhoods connected by the primary network. The primary network grows with the increase of traffic, and secondary network with a less traffic. Here is the water. We can notice the primary network connecting the amalgamation, the public space, and the coral parks. And as you can see, away from the coast of the city, the networks start to lose energy. And with that, we can perceive a change of color.
So a quick overview of the deployment process of MAP. We take you to the quick public unit zoom in.
Go to the city center, go to the image.
Okay. So here's like the final zoom in of our city, and that's the entire port of our.
Yeah, sorry girls, but to take you need to be able to explain it.
Yeah, sorry, thank you.
Sorry, thank you. We have comments.
Beautiful project, well put together, a lot of layers of complexity coming together. You just started working last chapter, and I'm happy to see like how you're actually like all the previous chapters somehow work, right? Like it does look like you started actually this project from the beginning. There is some work that has to be done, especially in kinesis, as we know. But in this chapter, I think that you were trying, like it looks like you were trying to optimize and then tell the story, but it's still like you still need to work on that, right? Like the multitude of information that you're overwhelming everyone with. Like if you cut half of the information you have on the board, you might actually have even a stronger story, actually. Like when you're talking about the mode, for instance, we know how mode looks like. You don't need more than one picture, for instance, right? So this is something that you do need to think about, like how actually to tell the story in the time frame cohesively, because this is like what also makes and breaks the project, right? It's not just the representation, the design, the thought, the skill that goes into it, but the presentation that it's not accurately representing it or it's not doing it justice. It's actually equally as important, and it can make or break a project. It can make a sale, you know, like in the future to an investor or not, right? So that's why these presentation skills are so important. That's why we have these major presentations after each chapter. We're not waiting for just the last one. So please, next time around, rehearse. I want to see a very cohesive presentation. Other than that, on chapter 5, congratulations. I'm happy to see all the work you've done. For me, like it's beautiful, it's cohesive. There is a lot of layers that work well together, in my opinion.
Thank you.
Thank you.
Just stay on one image, please, because when we're moving, it's blurry.
I think the reason that they also took so long is that, I mean, from what I've seen, they worked so much on this project. They have so many experiments. Like the girls really like worked a lot on this. I like the project. I like how it comes together, but it just feels at the end that there are too many things overlaid one on top of the other. My personal opinion. And also with the glare, like the fact that it's, I mean, the representation, in my opinion, I like the idea of neon glow and everything. It's just that there are so many things one on top of the other, and I just feel that in your progress, you had points in which things were more like would be easier to read, and it just feels that maybe if you were to insist a little bit more, like take a break for 1 week, then maybe look at it again with fresh eyes and see which are the places that you want to emphasize and which are the places where you need less, like more void spaces or more like less, yeah, because everything in the final maps feel like you could look everywhere and everywhere you would find something interesting. So for me, it seems that it's a bit too much, too many layers, or maybe the way they are.
But doesn't the color coding help you like navigate easier from other projects, for instance? For other projects, like you couldn't really see where the clusters are, where the areas are, what the differentiation. Here you have all this like insanity as amount of information, but I think that like for what they're doing, like I do think that they're somehow like successful because of the color coding.
Yeah, what Madeleine sees as you know, like overwhelming geometry, I see it as a big advantage of this project.
See, like everyone's looking at it from a different perspective.
Yeah, I mean, what exactly
valid,
what
right?
he said, like I thought exactly what he said about like whenever you look, you find something interesting. I think that's actually good. But maybe the clarity of the presentation is what is lacking. But this is probably the first project out of all of the ones which we saw, which kind of reminds me something that could, yeah, like it is actually some kind of a city, right, or urban, or you know, like major plan, right? It's in this case, it's yeah, like everywhere you look, you see some kind of urban, or maybe not urban, maybe it's a different scale, right? But I mean, like you
even
see
urban
some
structure,
kind of
something like
features, like openings, right? Some vistas, some perspectives, right? And then you see some how do you like empty spots as well? There are like empty spots as well, which don't seem empty, but I mean, they are, right? But I think that, and when you have the one map on the left, like with the Tokyo name, you know, that those kind of squares just remind me of the Forbidden City in China, right? You have like something like that, and that's actually good. It's not like a uniform pattern, right? It's not a marble. It's actually, it looks like something could potentially exist and make sense as a like very chaotic but city, right? Or even if it's a bigger scale than a city. I'm not really sure what's the scale here. That's another thing. Yeah. But yeah, you say the public city features. Yeah, that's what it. Yeah, so it's a city scale, right? But yeah, I think that's my.
Thank you.
Yeah.
Thank you.
Thank you. Great project.
Thank you.
6. Elena and
Before we move just
Yeah.
with the next project, I'll have to run in 10 minutes, unfortunately. I will watch the presentations afterwards. I'll try to connect if I find a chance again, but I doubt it. However, I just want to say a very big thank you to everyone for the tremendous amount of efforts, not just in this chapter, but throughout the whole program, and especially like Madeleine, Kirill, Mateusz, like you've been really amazing, and thank you so much like for really like sharing your knowledge and being so generous really with your time and the excitement that you're showing and the love towards like the work and the students. It's amazing. So keep going, guys. Like we'll keep in touch. I know that we have a couple of weeks off, which is good. Like enjoy them, take some time off to refresh, restart. And we'll see you with the next semester. It's going to be very exciting. I'm reminding you for the RoboLab, whoever hasn't purchased their parts, please do. They do take some time, like they get lost, something doesn't work. Please do this as soon as you can, because otherwise you won't be able to participate fully, right? So this is very important. But overall, I would say like there is a great improvement, great learning opportunities, and I see that how everyone and each one of you guys are growing throughout the project. So thank you so much.
Thank you. Thank you. It's been an honor and it's a pleasure. Yeah, thank you.
Yeah, we're not
Bye
finished.
from me.
So yes. Team 6.
So we're good?
Ready?
Yeah.
Okay. I'm Brian and my partner is Elena. We titled this chapter Interweave. Our project, Ouroboros, envisions a society rebuilding from collapse, a collapse caused in no small part due to the bionic and neuronic implants at the heart of our cyborgs, which, driven by capitalistic, consumeristic principles advertised and marketed, fomenting self-deprecation while conveniently preferring materialism as the cure, propagating misinformation and the spectacle more than knowledge or truth. But in the wake of the social upheaval, these same technologies, the implants, are appropriated as a remedy. Flows of stimuli are inverted, and people instead use them to engage with one another, to share themselves in a reciprocal mutual fashion. Since the first chapter, the theme of our Ouroboros has been mutualistic reciprocal relationships, whether between human beings as cyborgs, between these beings and their habitations, and between the larger environmental systems and structures of neighborhoods and cities. This ideology extends to vehicular logics as well, which work synergistically to transport inhabitants throughout the city. This vision of mutualism, which informs the logics and aesthetics of the cyborg world, is not simply ideological, but is analogous to the precedents on which this technology is derived, particularly slime molds and mycorrhizal networks. Thus, it may be understood that the relationship between the implants and the cyborg to the relationship between the cyborg and an overarching cosmogony are scalar and recursive.
In this chapter, we've been experimenting various slime systems. We've created different populations which differ in characteristics concerning density, speed, rotation angle, and other parameters. Through a catalog, we have examined how the parameters would affect the particle's movement. In general, we noticed that rotation angle meanders the curves. The higher the speed, the sharper the trace. And lastly, the sensor distance affects the scale of the pattern. The amalgamation grows and spreads based on fungal growth patterns, which give it the freedom to adjust into different situations. The types differ in scale and amount of corpuscles as they contour different parts of the city, from suburban to central areas. The corpuscles come together to form clusters which differ in main functionality. Altogether, they create their brand new preferable world. In the new communal society, everybody contributes with a small factory embedded in his or her own home. From the phase of collecting the waste material to the finest details of their development, they collaborate. Additionally, some take care of the nature. Different habitation types occur all over the place. High to low density areas or pattern growing from the edges inwards. Next. The network continues on a local level for further distribution. Programmatic public spaces occur in between the corpuscles with meaningful activities such as meditation, creativity workshops, or even loud festivals. All this enhances the empathy in between the inhabitants.
In this chapter at the level of cosmogony, we've created a series of overlapping, intersecting networks based on temporal increments respective of the deterioration of old systems and rebuilding of a new society following a societal collapse. The poorest neighborhood, what the hell? Sorry, we had technical problems. The poorest neighborhoods are those first to be most heavily afflicted, becoming ruins as infrastructure and buildings degrade in the wake of collapse from looting, calamity, and neglect. As inhabitants abandon them, they relocate to places where a modicum of stability yet persists, parks and the buildings that surround them where wealth has slowed, encroaching entropy. Over time, dilapidation diffuses towards these centers, a gradient of decay from low-income areas to those of wealth and prestige. But as the degeneration expands, so too do opportunities for reclamation and recreation. As cyborgany begins to expand its search radius of resource reclamation, their paths begin to intersect and merge, establishing stable networks of long-term use between the most heavily populated areas, i.e. the parks where the scenario begins, which in turn become the major networks. Simultaneously, as the materials are sought out, their availability and the ability to find and exploit them is differentiated according to the initial wealth distribution at the onset of the scenario. This creates secondary and tertiary search parameters that inform the aesthetic of these networks according to these search logics, which are reflected in their emergent qualities. These qualities in turn inform the distribution, density, and programmatic aspects of the amalgamation that emerges from the networks. The pink is derived from the high population density remaining post-collapse, establishing thicker, heavier use path. They are public and private, they have the highest density of traffic, and they are primarily a source of destination. The peach are interstitial transitional networks, also high density, derived from the conflicts of differentially affected neighborhoods. Their disposition establishes areas for public spaces and venues. The emerald results from extended searches from core areas, passing through median intact regions to peripheral areas, chiefly ruins, initially established as transport networks. Thus, the paths are more elongated and direct, and they are the fastest. The violet has the erratic nature of the violet is due to their formation as cyborgs search the wastelands for what remains among the pile of debris. Reclamation. They're the slowest because of the meandering nature and limited carrying capacity, thus giving rise to predominantly suburban residential neighborhoods. Over time, these networks shift and wander as they seek new materials, transmigrating the cities and neighborhoods along with them, growing and contracting in accordance with resource availability, leaving behind topological meanders that nature may ultimately reclaim, consequently expanding the parks and connecting one from the other to form vast greenways. In a reciprocal process that reifies our overarching concept of mutualism, wherein nature and cyborganity simultaneously interpenetrate and separate, an interwoven dichotomy of past, present, and future, of form and void, and of the technological and human. Thank you.
Thank you for your presentation.
Thank you,
Although we are up 1 minute, I think you explained pretty well.
Thanks a lot, guys. It looks like a very, very coherent project, and you have everything there. I guess I don't really have many questions, except for maybe, you know, since we're establishing something that resembles the society that exists right now, why do you think it won't go in the same consumption-based, down the same consumption-based road that formed the problem that you focused on in the first place?
Well, I mean, in the initial phases, what we didn't really talk about was in the prosthesis level. They have interconnectivity with each other. And so essentially, I can't, you know, without getting too deep into it though, the idea being that they are have greater capacity to share both emotion and thought, even memory. So in that sense, the idea or the hope would be that it establishes a greater sense of overall humanity. And I'm sorry, I can't think of the word, empathy.
Okay, so that is something that you are expecting from that kind of growth of their environment, of their new human environment to resemble. Is that a right way to think about it? That this will kind of show?
Yes, because like if you went back also one more chapter in kinesis, the idea applies here too, that we establish more or less meandering paths and networks. And even though maybe a little bit obtuse or obscure, the idea being that we're trying to transgress normative ideas of time and space and movement to create a society that focuses more on the present and not necessarily as concerned about their ultimate destination or the quickest ability to get there.
Yeah, and
so
that is where the consumption is being defeated, because there is no destination, but there's, yeah, I really liked also the speed kind of hierarchy that you build there, that the greener areas are slower and that kind of stuff. That, yeah, that showed me.
No, that's a
great project, great project. Really, really love your solution of that problem.
It's really great project. Also for me, sorry.
You go ahead.
Really very well continuing your story from the previous chapters. Congratulations. And also on the presentation, it was really nice. Thank you so much. Thank you.
I think we had the same feedback. I agree with you. Like the presentation is like, I haven't seen this while we were working together, but like you're very good with presentations as well. So yeah, it really emphasizes everything. Yeah, this is a good example of how you can use graphic design in your to help your project. So good job with this, and I like the differentiation between the different zones. I like the fact that in some parts Like, I think you've added in the meantime the density. Is that true? Like, you've added
Yeah,
more density in different parts?
We changed the script a bit and added some other parameters that gave us better results.
Yeah, yeah. It shows. It shows. It looks good. It looks good. Congrats. I really like it.
Thank you.
And a great concept.
Great, great. Thank you, thank you. Great work. Let's Jimmy and Infi.
Hello.
Hello. Okay, so we're gonna start. Hello, I'm Fatima.
I'm Shingo.
And today we are presenting the organ print. So there are two types of choices individuals make to represent themselves, the choices of what they decide to reveal versus what they decide to conceal. These choices define two sides of identities that could be manifested throughout their lives and after their death. This is the focus of our project.
Organ print life prosthesis aims to create complex interaction between by transforming programmable garments into physical abstract art pieces. The user information will later guide the growth shape of her organ print after death.
Once an individual is dead, the organ print will begin its transformation into a fully developed prosthesis for the living to use, and through which they can have a different perception of the surrounding environment.
At the corpuscle level, the coexistence of both corpuscle will force a tension that drives a unique and dynamic form of existence. The life adopts a rigid and artificial scaffolding language, representing the construction process of self to create flexible living units.
The corpuscle of the dead is an AI grave that exists in an AI cemetery library where the information of the dead are encrypted and represented virtually as a pattern in the inner shell of the grave. For the amalgamation, our aim is to maintain that interconnectivity between the living and the dead at the city scale. In our system, the living corpuscle starts its aggregation from the ground up, allowing the death to aggregate from the top down. Both systems meet and interweave in the middle, allowing for conditions for existing and competing to take place in between these two worlds.
Reassembling corpuscle parts, the more amalgamation building grows in height, the more the shape will resemble the death unit. And this is the life building up sequence.
The buildup of the death amalgamation branches in its aggregation to create pockets for the public spaces as it meets with the life formation. The network of the death, sorry, go ahead, Jinio.
Sorry. As the amalgamations grow in height, it is important for organ print kinesis to strengthen the connection between communities vertically and then spreading out. Therefore, life kinesis develop a transformable elevator that moves vertically and horizontally following the magnetic tracks. The stations are located on the surface of the amalgamation buildings across the floors. Zooming out, you can see how these massive tracks transition into cities and buildings.
The network of the death corresponds to the verticality of its amalgamation. The points of clustering becomes the focal locations for the network to expand laterally, creating a series of network clouds along the amalgamation.
Please, let's go to the Cosmogony.
Yeah, next we can go.
In this chapter, we use Florida as the site. We take the existing urban areas as anchor points and move them flowing inwards projection to create boundary lines.
And also we have identified areas where cemeteries are located and overlapping that with the locations of cellular radio towers. The resulting clusters will become the main area where amalgamation towers will be located. The first step towards developing our system is the formation of the major routes around those identified clusters. In the second level, you can see both the medium and the minor routes emerge to connect the smaller areas. And at the third level, we can see how both life and death starting to form their own emerging networks, where they interact together and form this interweaving system around the bigger clusters as well as the amalgamation towers. Lastly, The resulting public spaces could then be generated in the areas in between those networks.
The interaction of amalgamation within the site can happen in forms of any of these conditions, where the system could take place inside of another or transitioning from one to the other. Replaced by simplified amalgamation diagrams, these conditions are represented of the relationship between life and death as manifested in the scale.
This is a zoom in that we can then, we can go to the big map.
And
this is a map. Yeah, go ahead.
Sorry. Go ahead, Fatima.
So this is a map where all these layers that we've just explained overlap together to form this formation. Thank you.
Thank you.
Thanks a lot. And it's, I mean, wow. I'm a little bit surprised how many groups chose to work on the concept of life being, well, emerging from the death. And everybody has a different approach there. And I really like your approach because it's so metaphysical. And in the same way, you know, some people might even think that it's maybe a scary way to think about it, but it's not. It's very optimistic, I guess, and very pragmatic. And yeah, I really like your result because it actually looks like, you know, it's not something typical, and but it still makes sense, and it is very organic there, and you can clearly see the hierarchy in the usage of space. And yeah, I mean, very, very interesting. I'm not sure what else to say. Thank you very much for sharing.
Thank you very much.
Thank you. It's really amazing project, one of my favorite, and this last chapter is unique as the previous, and it follows the scenario. So I can't wait to see the final presentation.
Thank you.
Yeah, this is really the most, like, one of the most complete projects, I guess, and you really demonstrate that you can put a lot of information without actually abstracting one information layer from another, which is really good.
I'm sorry, can you just zoom in a little bit while we're discussing?
Mm-hmm. Yeah.
Into the main plan.
Yeah.
Or here, yeah, fine. Thanks.
Yeah. It demonstrates like a bit of like, I don't want to offend you, but classical thinking about urban design. I mean, right? But you have different layers. I mean, don't find it offensive. It's actually good that you were able to like force or steer, maybe if it's a better word for that, like steer the generative emergent algorithm to do what you really want, right? So it's actually, yeah, it's very good. Yeah, thanks.
Thank you, appreciate it.
It's a beautiful project, very clear. You know, I agree with Michael's comments in the chat. Like the weights of everything are very good. It's complex, but it's clear, easy to read. The colors are great, the storyline. I'm very proud of you. You've done like a really amazing project. So congratulations.
Thank you.
Thank you. Thank you very much.
Like the final few days of this week, that you had a lot of things, and I'm glad that like you taking the feedback from last week and from Monday. So yeah, great stuff.
Thank you.
Thank
you.
I can add maybe one sentence. Everything that everyone else said, yes, and just the public spaces areas for me are not fitting yours, like the style of the map not your style, but just the style of the map is just a little bit like, yeah, you know.
Yeah, I feel what you're saying. Yeah, I totally agree. I mean, that was maybe one of the best that we had so far, and this is not the most successful, but I think that's what yeah, what we have for now. But yeah, I get your point.
Let's move on to team 4.
Yeah. Thank you very much.
Violeta?
Yes, hello, how are you? Let me share the screen. 1 second. Can you see the screen?
Yes.
Okay, so I'm just going to. My mirror is always a little bit slow, so okay, I will be presenting new species. My name is Julieta Guizermet, and this topic is about the evolution of the human being, adapting different capabilities from different species, and also being able to start relating in different senses with the environment and with different species as well. So always in relationship with the magnetic fields, the energy, and also able to perform with swarm intelligence. So just take you to the processes of our new species or new species. It's always, all of our design have maybe main 3 characteristics, where we have a performative skin, an energy distribution system, and an energy input core. So all of these will be distributed throughout the systems, and it's how we will start anchoring to different settings and different environments. Our corpuscle is also the same. It's more of the same, where we have different distribution spaces with one main anchor point to the terrain or to the side, relating this to the magnetic energy of the field or of this side, and also distributing it to the different areas of the corpuscles. In terms of the amalgamation, when they start agglomerating together to different cities, we find the corpuscles join in different areas, but always having a vertical circulation and a main station, that all of these will start working as an energy network. And this is how the city will keep growing and growing and growing. So what you will see in terms of kinesis, you will see more of this tower element, where we have the amalgamation, the station, where is the production of energy as well, and all the networks where the transit will be distributed, different public transportation or a smaller scale transportation as well. But with this magnetic field and the magnetism between everything, you know, the corpuscle, the cars, all the movement, it's starting to generate this big energetic network that will allow the city to keep growing based on this one. So in terms of the cosmogony level, we have studied the map and understand that maybe not in every part of the Earth we start having these magnetic fields on Earth. But we understand that with the, for instance, the energy flow of the what you will see here in this graphic is the energy flow of the semi-diurnal lunar tidal wave that will start generating some energy. So we understand that with water or the cercanity to water, we could start incorporating this energy to our city in order to keep growing and growing in terms of the energy and what we need. Also, it has been studying the way, for instance, like how birds migrate from one side to the other one. So in all the movement that we have and the energy and the synchronization between the neo-species with different species and this magnetism, we're just understanding where we can be taking energy from. The site we have picked for this specific chapter, the cosmogony, it's in the desert of Atacama in Latin America. So you will see a very vast area open, and also some areas with water right next to the water. What you will see in our legend, oops, sorry about that. What you will see on the map later on are the water channels, or just the water energy, where it starts from different selected areas from the earth or the movement of the water that will slightly distribute towards the coast or the shore where the city will be located, and then growing inside as well. The main routes on this desert area and how it is starting to connect maybe in some energy level to these magnetic points in the water as well. the medium roads, where we start seeing more of the areas where the amalgamation would be bigger clusters of them, and also the spaces of the open areas for this entire region. And then to another level, the smaller routes that will be more of pedestrian and also more for like a small type of private circulation as well. As I explained when we were talking about the kinesis chapter, all of what we do here in how we move and how the energy start transferring and how we transfer from one system to another one, from one tower to another one, and all the entire city start working with this energy, this magnetism, and this free type of movement. Free type of movement within these, well, sorry, all these different type of amalgamations. And then we have the close-up of, like, you know, how the water hit the land, the map, and the amalgamation itself. And the big map, let's zoom out a bit more. So this is the all the layers come together in the big map, where really the orange, sorry, it's very slow. So where you could see more of the orange cluster, or more of the, sorry, my computer, my internet may be very slow. Okay, so more of the orange base layer is more of this energy flow and free movement, and then all the different type of roads as well. The red one where you could see is more very the main ones, and then the open spaces, which you could also see. It's a bit hard, I know, some of the layers, but you could see the terrain also with some different heights perhaps, where it's more open also to the east of the map. So, yeah. Time.
Just zoom in
So
on the
that's
big
for
map,
the
please, and stay there. Thank you.
Sorry, it's hard to, I mean, I can just zoom in.
No, it's, yeah, that's the good scan. Yes.
Okay, so you will start seeing, you know, more of the water flow, how the energy of the main roads also start trying to get within this dialogue of the...
Let's see the feedback. Yes.
Say again?
You over time finish the presentation, so we'll get the feedback.
Okay, I was finishing it. Sorry, I got lost with your
Just
comment.
stay on the map, please.
Okay, and then just different studies of the different options that were studied before adding those layers. And that's it.
Yeah, it didn't work on the presentation. So you didn't explain everything correctly, I guess. But I would congratulate you on the map, because it's the only map that is on black, on the white background. It works.
It was a bit tricky. I was really thinking to change later on, just because it's for the red. I feel it looks like Crayola map right now with all the red stuff. So yeah, I tried it, you know, last time in the beginning of the week I was like playing with a darker background, but then we just decided to stick to white. But it's harder to manifest more of the brighter area, or more of like a clear connection, like a straight line in a way. But yeah, it's white now.
I would add one short comment, and that's for you and for many of the teams. We're at presentation number 5, so by now you should know what it means when it says 5 minutes presentation. And I think just not respecting the time is something that really many teams need to work on, because at the final presentation, if we, for example, let's say, I don't know how many minutes it will be, but if they're like 5, 8, 10, however many minutes per team, it needs to be 10, not 15, not 12, 10 minutes. That's it. We cannot, like, for me and Tunk is very annoying and unpleasant to have to interrupt you every single team, and you cannot finish your presentation. So let's say this is one thing you should work on. That's my feedback outside of the actual.
Guys, we should just time your presentations like before you start presenting.
But we do, they do, we rehearse. It's a whole process. Still, we are at some minutes that nobody can count.
It's that artistic energy that you cannot control or embed in time.
Right, but
yeah, I'm just joking. I'm not saying this should be that way. Yeah, but anyhow, we should comment on the project. I love your idea about the energy flow and about investigating into magnetic fields and how they impact the water flow and how water is essential to the energy flow for the humans as well, because it's obviously essential. You know, you might make a case that it doesn't carry calories, but it is essential for life, right? The only thing that I don't really like here, because, well, first of all, okay, let's start with what I like. You have the division in the terrain, you have some gradient there. It's not all the same, but your amalgamations, they lack diversity there, because you explained that you've actually planned the public areas and so on, and this is visible here, but the amalgamations do not tell that story. You don't have the distinguishment between those more small private areas and maybe larger buildings and public spaces. So maybe that is something worth emphasizing in a more readable way. But all in all, yeah, I really like that the final result. It is a project. It is obviously something that has harmony in it. And yeah, the only thing that I like here is the diversity in your amalgamations. So all in all, great job, and maybe, you know, that is something to consider for the next step.
Agree.
I think in terms of aesthetics, like you have good aesthetics. Yes, it's hard to do a map on white background. That's why I was insisting on black. But you almost managed. Maybe if you made the amalgamations on a different color would have made them pop a little bit more. Maybe also having a differentiation between sea, like water and ground, just in terms of colors. Other than that, like I think, yeah, you have like different types of networks. They overlay in a way that's quite clear, and I think, yeah, I mean it came along okay, considering that like at some point we were like thinking like what are we gonna do, but we managed to pull it off. So congratulations on that. But I think, you know, if you have more time, it would really like help to, yeah, maybe make a zoomed in part where you show things a bit more clear. I don't know, things like that. I like showing us a little bit more work, but I think, you know, you have like a good start. The aesthetics are right. And yes, it's a good start, and I think it's promising, but it still needs more work, or a bit more work.
Thank you everyone for the comments.
Thank you.
Next team, Alma. Brace yourself. We're going to this.
Okay. Dear Galactical Geographic Society, we are space archaeologists Nadia Kutreba and Pedro Venegas, and we have a unique artifact to present.
We knew that the origin of our galactic civilization started on a tiny rocky planet on outskirts of the galaxy. Legends point to Earth, but there was no proof to that.
Until today. But first, let's talk about the history of Alma Society and all we know about it.
At the beginning of the space exploration, humanity was in crisis. To save the planet from mass extinction event, humans enhanced themselves, their devices, and even architecture with a creative artificial intelligence, autonomous living machine algorithm, ALMA. It built a society that was based on core attributes: communication, data exchange, autonomy. On a human level, they implanted ALMA directly into the central nervous system. It gave people the opportunity to perceive the data of the world and innovate power to save the planet. Humans started to explore deep space. Living mobile units, corpuscles, enhanced living experience in space and collected data that express itself through the design. ALMA people settled on low orbit near the planet in vibrant, always shape-shifting settlements. Corpuscles brought the data from space missions into the community and aggregated around oases with resources. Inside the settlements, they used smaller, agile, personalized vehicles to jump around, space hoppers, and magnificent space worms to travel between settlements and interplanetary.
As you may see here, this 3D map shows how ALMA people took their first steps to become a galactic society, proving that everything we know began in the Earth. Even in space, ALMA people developed certain types of patterns based on existing orbits. There are 3 distinguished stable orbits around the Earth. The lowest satellite orbit, which is the closest connection to the Earth's surface, low Earth orbit, where most settlements are, and geostationary orbit, where we'll find all types of production facilities like gigafactories. In addition to them, the ALMA eyes are located in what we know as intermodal orbit between the 2nd and the 3rd orbit, basically to accommodate interplanetary and interstellar travel. But there is a 4th one, a dynamic one, the transit orbit, the one that connects the rest of the 3 stable orbits, which is mostly occupied by space worms, the ones that move people, deliver cargo, and data between them. To reach to this point, several steps were taken previously through generations. So let's have a closer look at them. 3 main orbits are identified to begin the population. Each orbit has a specific distance and inclination. Then the population begins. The density of settlements varies depending on the orbit. The most populated is the habitable, of course, and all orbits connect in a way to ALMA eye intermodals. At this stage, the network comes to life. Here you see how the living entities of ALMA world start to communicate between them, exchanging goods, data, and experiences. As a result, an always changing network is created through generations. And the most interesting things happen when the transit orbit intersects one of the stable orbit. In order to understand what's happening at the micro level, we took a section of this 3D map and projected them into a bidimensional one. Let's have a closer look at this event. Here, we see the main streams of traffic and location of settlements in this transition event. At macro scale, it's not possible to see how local entities interact with each other. That's why a micro simulation is introduced here. The streams on both orbits have different properties like density, direction, data type, etc. All of these influence each other's behavior, creating a unique micro network. Then, on top of the network, there are starters that are at the core of any settlement, and the deployment on the neighborhoods is happening around the starters along with the network. Finally, between settlements, there are special infrastructural objects like recycling centers, data storages, and research facilities.
The typology of the elements in the ALMA world are core elements, neighborhoods, communal infrastructure, and transportation. Settlements differentiate depending on which orbit they occupy. This is the moment of the transition event. The regular life on the stable orbit is about to change. Here is a regular day on a habitable orbit. People travel between neighborhoods and settlements. Between settlements are community infrastructure, recycling and research facilities, and the knowledge of ALMA society has been accumulated in data storage. On the transit orbit are special type of amalgamation logistical centers. Inside the starter is a transfer station for traveling to the next orbit or ALMA eye. The bonds are storage for data and cargo. Space worms are swarming back and forth to facilitate the exchange. In intersection of orbits, the settlements that are inside the transit streams are under the most influence. They exchange data and resources with the transit network stations intensively. Later, they will redistribute the resources through the rest of habitable orbit. The process has already started. So, this map is a unique artifact of the dawn of a space exploration and space civilization as we know it, and it started on Earth. Thank you for attention, Earth descendants.
Right on time.
At least once.
At least once.
I really loved your story. Yeah, I mean, it's so broad and with a huge amount of details, but not too much. You know, you really were able to create a very polite narrative where everything goes, like, you know, all the details, they emerge at the right time. So there's no way to be bored or maybe overwhelmed with the amount of information. So yeah, great result for that. And in terms of your project, well, I also think that there's everything you needed, everything a project of that category needs. You've got the system there, you've got the hierarchy in that system, you have the philosophy, first of all, and you have, well, you've asked the questions and you delivered the answers. So yeah, I just would like to thank you for that. And I have no critics whatsoever. Thank you for sharing, and thank you for the narrative. And that's, you know, it's very complete. So that is something that you can actually show, yeah, like in that way. I mean, you know, the only thing I could say is I would like to hear more, but we don't have time, unfortunately. But you know that this is very good. Thank you.
Thank you.
It's an exceptional project. Thank you so much, guys, for all your efforts through all the chapters. And it's always a pleasure to hearing you and watching the presentation. It's really amazing. Thank you so much.
Thank you.
Yeah, I can add that this is an actual Cosmogony level network. And also I really like the eye that we can see here. I don't know if it's intentional. Not this eye, that actually when you zoom out.
Oh, yeah, more or less.
It's an eye.
Yeah, you look at Alma and Alma look back at you.
Yeah, always.
Yeah, exactly.
Yeah, you nailed the title, didn't you?
Yeah,
at all levels.
Great job, world-class project. We have everything. I wish like I have like a small book with like every piece of your presentation. They're so well worked, and graphics and storyline.
It's coming.
Thank you for the project.
Is it really coming? Someone said that it's coming. It will be cool.
Yes.
Yes, it's really coming?
Presentation, there's a book delivery by the end of the master, so every project will have.
Wow, that's great. That is great.
Of course, is there masterpiece?
Yeah, right. Yeah.
There will be some extra of Alma World, dark parts of Alma World.
I think you should send us all special small gifts per post. Like I will be expecting that on Alma gadget with the book copy. It will be very cheap to do that.
Thank you guys. Thank you for the work. Amazing. And
thank you so much
for the next semester. Yes. Okay, final team. Let's see Alice and Sam.
Okay. Hello.
Hello.
Hi.
Hey everyone.
Hello.
Hello.
Okay, we'll start. Hi, I'm Alice, and this is my partner Sam. Welcome to EndoSyn, where we propose a solution to alter humanity's parasitic relationship with the world to a symbiotic one. Our current times of isolation have deeply altered ideas of community and interaction. How does one form community during this time of isolation? How does one experience touch without touching? And how do we regain this connectivity not only as a species, but with the planet as well? In order to reestablish these connections, we analyze examples of sea animals that utilize a sixth sensory organ in order to interact with each other and their surroundings. This interaction is reliant on electromagnetic bacteria that work symbiotically with the host in order to navigate their surroundings. This bacteria is the core component to EndoSyn.
We implemented this logic for our prostheses that host a multitude of bacteria on a spine structure that is asymbiotic with the host to increase connectivity with those around them and synthesize clean oxygen. On the corpuscle level, the architecture will similarly host these bacteria like a trellis in order to transform our currently isolated and polluted human environments into seeds of life and hubs of connectivity. We analyzed the city of New York and how this system of growth and rejuvenation could be implemented into each neighborhood, similar to the High Line, by connecting isolating environments with communal spaces. And on the kinesis level, we established essential networks to connect these neighborhoods in ways that encourage interaction, implementing public and private transportation accessible to all.
As we move to our final stage of cosmogony, we utilize the logic of these dense, congregated city zones as a powerhouse to distribute and channel this bacteria to outer rural areas, revitalizing and rejuvenating environments that are on the verge of being unlivable. I will walk through the logic of our cosmogony phase from a micro to macro scale. The bacteria serves as the interface organism for all connections. The denser the growth, the more connectivity and cleaner air is produced. Ferrofluid is an electromagnetically polarized liquid, which we will utilize as channels to attract the growth of bacteria. We analyze the data map of bacteria congregation within New York to best understand the areas with the highest potential for connectivity. Additionally, we integrated subway maps to understand how these zones could be connected with existing channels beneath the surface. This network of ferrofluid will act similarly to an irrigation system, bringing nutrients to surrounding rural and unlivable zones. Visually comparable to the rich life that surrounds the Nile River in the eastern desert, these channels will attract new growth of bacteria and start the building blocks of life again.
We analyzed the various behaviors and conditions that affect the ferrofluids in order to develop these networks. Here, we utilize Houdini and Nuclei plugin in Grasshopper to create various scales and patterns of growth. Additionally, we use various subways, maps, as a basis to utilize these existing tunnels as a network. To add the richness, we utilize Houdini to replicate a reaction diffusion algorithm and then translate it into nuclei. We combine the two networks, bringing land and water together. Here is a breakdown of each component in the network. We begin with the contours defining New York City surrounded by the Hudson River. The organic ferrofluid networks are specifically constructed beneath the Hudson River as a means of bringing the electromagnetic charge from Manhattan to the surrounding areas. The subway connections utilize existing underground networks to distribute the congregating zones of bacteria, and the amalgamation sprout with life in the areas of rich bacteria. The public zones are encircled by these dense areas as a powerhouse and sources of energy that eventually funnel into the river networks. Here is a growth analysis of the ferrofluids distributing through the network, where we can see how we interact and work with the different variables within the algorithm to generate different patterns, behaviors on the ferrofluids. The network of the endosym transforms polluted environments and elements of humanity into sources of rich nutrition and life. Each relationship codependent and symbiotic with each other, as nature is in a constant desire to self-balance. The Cosmogony network acts similarly in distributing and balancing as a way to propagate a new life and a new future for our species and our planet. Thank you.
Thank you. Thank you guys for being on time. Great presentation. Congratulations. I know that we had like a lot of we have a lot of exploration, a lot of trials and errors, but in the end we got there.
Thank you.
We developed a whole new system.
Yeah, it was fun working with combining the Houdini and the nuclei together.
It's really amazing project. Thank you so much for all the efforts through the chapters, and it concludes the scenario very well. So really nice one.
Thank you.
Any other
Thank
comments?
you for the work, guys. It's like, it's been so complex with like working with two systems, integrating them, keeping the storyline, using data from the maps. Like, it's a very complex project, and I think in the end, it looks very good. The only thing is like, I think that I like a lot the process. The only thing is that with the final map, it feels like this, like for example, those delimitation zones with those lines are like taking a lot of attention in the detriment of what happens with the patterns, but that can be easily fixed. Yeah, I mean, I can appreciate it from the like amazing work with the reaction diffusion, amazing work with integrating the two systems. Yeah, it's been a lot of work. It worked really hard, and it shows. It's like, yeah, it's complex, but it's also easy to read. And yeah, my only concern is with the final map, that it's like just those thick lines. But yeah, like I really like the project, great work, and thank you for the work, and happy to have met you and worked with you. It's really nice. So keep on the good things, and I'm sure good things would follow.
Likewise, thank you so much. It was such a great experience the last couple of weeks, and we've learned so much. So I really appreciate it.
Thank you. Has been a great experience.
Thank you very much for the project, and I just wanted to add a little something there, because yeah, it's a great project, and you did a great work with the colors and actually blending all those techniques to generate the different types of geometry together, so it looks pretty coherent. Maybe the amalgamations is something that I think you could work with more. I mean, the distribution of the amalgamations there on the map. And also, I just thought of one thing, that during the presentation, you've focused attention. I mean, and it's just minor detail, but you've been focusing our attention on also what tools have you been using. For example, that we used slime molds here, that we used, we used nuclei here, we used other things here, right? It doesn't matter on that level of the story, because those are the technical details that, of course, are very appropriate for a technical presentation, right? On that level, I think in the future you might want to focus first and foremost on your concept and on talking about that, and maybe in the end, if you have time and you find this essential and important, you can tell more about the tools you've been using, more about the technical details there. It's just, it's a more sort of coherent way to present your project. Just because then the one who's listening to you is not focused on what tools have you been using. Oh, okay, I never had a result like that. It's more focused on your project. So yeah. But the storyline I really liked it. That you've actually made it data driven and put some scientific kind of thought into that.
Thank you. Yeah, that makes sense.
Thank you.
Thanks for the comments. Thank you for the project, guys. Okay, that's a wrap. I just want to say that we have a 2 weeks break, but don't forget we start with the 2 labs, and the teams that still needs to develop the chapters have the deadline on the Friday on the week of the lab. You can also check that in the Airtable in the program. And
yes, very important. Don't forget, that's like crucial. Make it or break it.
see the scheduling and prepare for RoboLab. and have some rest, because you need it. You deserve it.
We had we had great projects today. Thank you so much, everyone. Thanks a lot to Madeline and Mateusz and Kirill for all the efforts, and all of you. The projects are really unique, and can't wait to the final to see everything wrapped up. Thank you so much.
Thank you.
Thank you, guys. It's been a huge honor and fun. Thank you. Hope to see you again sometime.
I hope the last presentation will be at least 15 minutes per team. It will be impossible to squeeze 5 chapters in 5 minutes.
It's not gonna be 5.
We are thinking about that, but yeah, we'll see. I will manage.
Yeah.
Thank you, everyone. Have a nice break and see you,
Thank you.
soon.
Bye.
Bye.
Yes. Have a nice
guys.
holiday.
Bye bye.
We are awesome. Thanks.